Okay, dear guests, welcome everyone. I have a permission to start our event. We are ready. So, pilots say, fasten your seatbelts, please, and we're ready to take off. Again, welcoming officially you to the NATO Innovation Challenge Finals, Lithuania. A little warm-up for your hands and palms would be great. So, short round of applause for official opening of the finals. And of course, we applaud each of us, everyone here in this room, because each of us are somehow connected, hosts, organizers, contestants, generators of new ideas, challengers. Somehow we are all on the same boat. And that is important because we share one mission, innovation for impact. We live in a quite turbulent world now, and really strengthening our capacity, our innovation potential, shoulder to shoulder, we can actually achieve great results faster, maybe more cost efficient, maybe more sustainable. So this is great what is happening when great minds meet together. My name is Ugnius Savickas. I will be helping and facilitating this event today here. My pleasure and my honor to be here and to listen to ideas that will be presented as a major and most important part of this event. Of course, first of all, we need to jump into welcoming speeches from our hosts and owners of this event. So let me invite and introduce Erika. Erika Kurochkina is Vice Minister at Ministry of Economy and Innovation. Erika, welcome here on stage. That microphone should work.
Good morning. Yes, that's great. Well, good morning, ladies and gentlemen. I hope that yesterday's evening was enjoying and you already warmed up before today's event. It is a great pleasure to welcome you all at the 14th NATO Innovation Challenge Final, hosted here for the first time in Lithuania, and it is a pleasure for me not only as a Vice Minister of Economy and Innovation, but also as a member of Vilnius City Council. So thank you so much for being here today. This event marks a significant milestone for our country, showcasing our commitment to innovation in defense. Hosting this event is not just an honor, but also witness of Lithuanian growing influence and capability in the defense sector. For a small country like ours, having 5 finalists in this channel is really a remarkable achievement. It underscores the talent, creativity, and determination of our innovators who are making a substantial contributions to NATO's objectives. By bringing together the brightest minds from across the alliances, we are paving the way for advancements that will enhance our collective security. Lithuania emphasizes the significant importance of defense innovation and dual-use technologies. In line with our commitment to fostering innovation, we are actively welcoming new players in our defense innovation ecosystem as well. Lithuania's defense technology industry is young, exhibits significant growth potential, with more than 100 companies contributing to its dynamism, including a growing number of startups. The trend in the number of employees in enterprises in the sector reached about 14% in the last 5 years, and the number of startups grew for 40%. Invaluable part of strengthening our inner defense capabilities is international collaboration and, of course, partnership. Our active involvement in initiatives like NATO Diana and the NATO Innovation Fund demonstrates our commitment to collaborative efforts. I would like to extend my congratulations to all the finalists. Your hard work, knowledge, and of course creativity have brought you here, and your contributions will undoubtedly make a difference. This challenge is not just a competition, but a platform for collaboration, learning, and of course, growth. I also want to thank NATO for this opportunity and for recognizing the potential within our small but mighty nation. Together, we will continue to push the boundaries of innovation and strengthen our collective defense. Let us use this event as a catalyst for furthering our partnerships and driving forward the innovation that is essential for our future security. I am confident that the solutions we develop here will have a lasting impact. Thank you so much. I wish everybody luck. I wish luck to the jury as well. So have a great and inspiring event. Thank you.
Erika, thank you very much. Thanks for a welcoming speech. And of course, this time has brought many institutions also to collaborate, so I'm very proud and happy to invite also Greta. Greta Monika Tučkutė is a Vice Minister at Ministry of National Defense for a welcoming speech. Thank you, Greta.
Thank you very much, Ugnius. It's really a great pleasure to welcome everybody in this event. Yesterday we spoke about battlefield experience and innovations in battlefield in the event that was organized by the Ministry of Defense. Today we are participating in NATO Innovation Challenge, and I'm very glad to welcome everybody, because I think innovations, they are something that we need to include into our capabilities. We need to understand how to use them and how to advance faster than our enemies and opponents. Only when we are quick enough, when we understand well enough what is happening in the innovations landscape of the defense industry, we are much more competitive. And we need to take decisions quickly as well, because it's not enough only to speak about innovations. We need to understand how practically apply them. So I'm very glad to see that there are many companies, there are many initiatives, and NATO is not standing behind, but NATO is on the same page. NATO is initiating these kind of challenges that are contributing to the innovative approach and technological progress of our military forces. We are living indeed in the very challenging time. Our enemies, they are not sleeping as well. They are applying everything what is new, and they are learning very quickly from the battlefield. So that's why we need to be agile, we need to be quick, we need to be innovative, and we need to be united. Thank you very much for being here. On behalf of Ministry of Defense, I would like to wish you all a very productive day, very interesting and insightful event, and we are looking forward to seeing all those innovations to be included into our capabilities and solutions. Thank you. Have a nice day.
Thank you, Greta. Yes, such an important message about being one step ahead. I think in business we usually use the word, fail fast to succeed sooner. I don't want this to be used in the battlefield. We need to succeed from the first attempt. So that is really very important. On the other hand, I would absolutely contribute to NATO being a platform just to, you know, look for those ideas that are probably sometimes born in garages and somewhere in the little small rooms to make it really NATO-wide. For the welcoming speech, please let me invite Brigadier General Ivar Noten, Deputy Assistant Chief of the Staff Capability, NATO ACT. Ivar, the stage is yours. You can use this or that mic. Mm-hmm.
Good morning, everyone. I will make this rather quick because I'm excited, looking forward to see what the competitors are bringing forward. First of all, let me thank the two vice ministers for being here today and hosting this fabulous event. Yesterday was actually really good, and we enjoyed both the full day of a seminar, but also the evening here in the museum. So it was a great evening. When it comes to the competition, I hope, jury, that we will try to be as neutral and looking for the good solutions. Normally we would say that being number 2 in battle, that is not a good thing. But being number 2 today, that's probably not so bad. It's probably pretty good. And maybe we can look at all the competitors and see if it's possible to combine their solutions and find even better solutions for the future. So with that, I look forward to the competition. I wish both the jury and the competitors the best of luck. Thank you.
Thank you very much. Thank you very much. Yes, we invite for the fair fight, and we will see, I think we will see really great ideas and great results. And I would love to invite Lieutenant Commander Pierre Delhomme, Innovation Branch, NATO ACT. Welcome, Pierre.
Thank you very much. So I'm Lieutenant Commander Pierre Delhomme. I'm from NATO ACT, and I'm in charge of the Innovation Challenge for ACT. So it's an honor to be here in the Energy and Technology Museum in Vilnius. And this event would not have been possible without the exceptional support and collaboration of our Lithuanian teams. So thank you very much, Vice Minister of Economy and Innovation and Vice Minister of Defense of Lithuania. Without you, this event would not have happened. So thank you very much. So the topic on demining has gathered immense interest, evidenced by more than 50 submissions, high-quality submissions. We had 52 submissions. And the pre-selection committee had the very difficult task to lower down that number to 11. So for the jury and the finalists, one USA competition could not attend by VTC, so it's down to 10. So that's good news for the participant and for the jury, a little bit less work. And talking about this, for all the finalists, you are in our NATO Innovation Network. That's very important. So everything about your solution will be in our database in ACT. So if we need, and we have a specific issue on drones or etc., we will contact you. And for the 3 finalists, I would like to say there's a monetarized prize from ACT. The third one will have $1,000, the second $2,500, and the first one will have $5,000. But above this, what's important is for the 3 finalists, we will bring them, we will invite them, and hopefully cover the travel cost to all our events ACT coming this year. And the next one will be in Lisbon, in Portugal. So you will be, for the 3 finalists, invited to showcase your solution and meet the partners. So this is very important. We are also honored to have distinguished guests with us today. A delegation from Japanese MOD, Ministry of Defense, that are attending here. So thank you very much for having this travel, especially for us. And we have also a delegation represented by the Greek Army, a Colonel. Thank you very much for everything doing this trip for us. We're all live streamed, and I know the Turkish delegation wanted to attend but couldn't, so they're looking at us right now, as well as the German Bundeswehr, and the Milenge is a NATO unit specialized on demining. They couldn't attend, so they're looking at us right now through the internet. It's live stream. on YouTube and Facebook. So today, I will just say it's not just a competition. It's a celebration of creativity, ingenuity, and international cooperation. And I look forward to the insightful discussion and groundbreaking ideas that will emerge from this challenge. So thank you all again for being here. And let us embark to this very exciting journey. Thank you very much.
Thank you very much. Thank you, Pierre. Thank you very much. Let me introduce the honorable members of jury, and I actually also wish that you have a tough job today. So I wish discussions will be really quality, and the contestants, please prepare actually to fight. At least, Mr. Pierre, at least we know who pays for the drink this evening, yes? Good. Let me introduce one by one, and please don't be so shy with applause, because that is also good for yourself to actually activate your blood circulation. Brigadier General Ivar Notten, Deputy Assistant Chief of the Staff Capability NATO ACT, President of the final jury. Welcome. Thank you, Ivar. Lieutenant Colonel Nicholas Kaudinov, Representative of Allied Command Transformation. Welcome. Thank you very much. Lieutenant Colonel Guy Dedeker, Representative of Allied Command Transformation. Thank you very much. Lieutenant Colonel Thorsten Ritter, Representative of Allied Command Transformation. Thank you for coming. Thank you very much. Adjutant Gino Lambrecht, Representative of Allied Command Transformation. Thank you very much. Thank you for coming. Mr. Marty Kazubowski, consultant from US. Thank you very much, Mr. Martin. Mr. Jerry Cronin, consultant from US. Thank you very much. Major Regimantas Balius, representative of Lithuanian Armed Forces. Thank you, Regimantai. Major Nerijus Milašius, representative of Lithuanian Armed Forces. Thank you very much. And Captain Mantas Liutkus, representative of Lithuanian Armed Forces. Thank you very much. Okay, dear jury members, so you have, I think you have everything set up. We will prepare for the first contestant. And actually, let me just remind you that our scenario for this challenge is specifically about remote explosive contaminated area recognition and neutralization. And we have 5 important judging criteria. Let me just remind to everyone who is attending here as a guest maybe, or to the audience that is remotely watching our event. And judging criteria are effectiveness, safety, innovation, scalability, and integration. So please attentively pay attention to these criteria. Also, the contestants try to emphasize and actually pitch it well. Myself, I've been in many pitch sessions. I've heard plenty of ideas, and it's both equally important. The idea itself, and of course, how do you sell it? So please, really, I wish all the finalists good luck. Fight for the first place, but as Pierre also mentioned, that fight is actually beneficial anyways. You are in the ecosystem, you are watched, you have been noticed, and it might be, actually, it might turn out in many other different ways. But let's have an, fair, but proactive and, I don't know, maybe very passionable fight here on the stage. Technicalities. For the pitch, you have 20 minutes, and then we have a 10-minute session Q&A for Q&A. So, of course, priority is always for the questions from jury. If there will be a situation that there are no questions from jury and we still have time, we will see. Maybe we will take 1 or 2 questions from the audience. If not, we just simply move forward. And as Pierre already mentioned, we have 10 contestants, so it's already, 1 step closer to the first place. We have a little bit of a change in agenda, so just pay attention, dear jury members. We will start from number 2. So we just simply reordered. So I invite team AAEG, Remote Explosive Contaminated Area Recognition and Neutralization, Pioneering Methods for Remote Recognition and Neutralization of Explosive Contaminated Areas from France. Welcome on the stage. Pleasure to have you here. Hello. Do you need another mic, or you will use one? Yep.
Thank you.
Good morning, everyone. And thank you for giving us the opportunity to present our solution today. So we are a group of 4 French companies with very complementary skills, but we are only 2 of us present today. So please, you can go to the first slide. Or is it me? Oh, okay, sorry. So this morning we are here to present our innovative solution to tackle current mine clearance challenges. We are also here because we wanted to meet other companies and to get information about technologies that we could also integrate in our final solution. And of course, if we win, we would like to finalize this solution and, of course, deploy it on the field. So this is why we are present here today. Before developing this solution, Lionel and I, we went to Ukraine to get information about mine clearance challenges. And this is very important to build a solution that is really adapted to the field. When we went to Ukraine, the first thing that we could see is a difficult assessment of the situation. Today, we suspect that very large superficie of the land is polluted, but we don't really know the exact size of the pollution. We have difficulties also to understand the type of munition that we can find. Sometimes there are munitions that are unknown from deminers. And the level of risk can be very different from a field polluted by anti-personnel mines or by bombs or anti-tank mines. So that the threat is very difficult to assess today. We could also see that there are limited resources in terms of deminers, but also in terms of equipment. So it's very crucial to make the best decision about how to employ those means. We could also observe that in every country, it's always the same. There is a very it's difficult to share information between the different stakeholders. So of course you have the army, you have the civil security, you have NGOs, you have international organizations. Everyone has information, but sometimes is not sharing it. And at operational level, there is sometimes a lack of consistency between equipment. We've seen in Ukraine, for example, that a lot of countries deliver different equipment, very high technological equipment, but the coordination between equipment is not there, and it can create some confusion about how the methodology to employ those equipments. So this slide is the conclusion of our observation after a lot of discussion with the users, and then we decided to go to this solution. Sorry, maybe the slide is a bit too detailed, but you need to understand that we wanted to have a system approach. So this is super important to have this capability of collect, compute, and process all the data in one command and control center to get the full vision on what's going on the ground. Then, of course, to increase the capability of getting the best information from the ground, we need innovation. Innovation on UAVs, for example, so combining different sensors, innovation on UGVs, innovation on demining machines in general. We will come back to this. Artificial intelligence, very important to help the deminer to do the assessment of the situation in real time and in an automatic way. And of course, at each stage of development of our solution, we use the feedback from the deminer, which is very important because it needs, in the end, to operate the system. Your turn.
Does it work? Okay. So hello everyone. So as Eve said, in the last few months and the last few years, something great happened regarding demining in France. So we have built a group of companies working together instead of being in competition, providing many solutions for demining. Could be equipment, could be services, and we have explored together the ways to work better together rather than competing against each other. So this is our solutions that we have put together and start to think at system level to be better than the sum of every equipment. So the system we provide is composed of many topics. So first one is surveys. So there is already a lot of expertise in France, and particularly in geomine, for doing non-technical surveys, technical surveys of the area. We also have some capabilities to analyze satellite images to see movement on ground from day to day using artificial intelligence. And the point of this system is to gather all the information that is coming out of this analysis and to georeference it onto a map so that at national scale you are able to see where the risk is and which are the areas that has to be demined in priority. That's one of the goals. And at operational level, you are also able to know what is the context of the area you have to demine thanks to our system. That's first topic. Then we also have a lot of capabilities for drones that can do some photogrammetry and embark a way to provide up-to-date mapping of the area you have to demine that will be available for all the other assets of the system in real time. So this is a second very important part of the system. And it can be compatible with many kind of UAVs. We have chosen one, which is one of our partners for this contest. But it could be also we could onboard almost any UAVs that has the mapping capability. Third topic is VTOL UAVs to be able to have like a very specific observation of a very particular area in order to be able to detect any threat or some level of risk sometimes using multispectral analysis, or it could be infrared, it's always combined with artificial intelligence algorithms to be able to detect a level of risk or some suspicious areas that we will need to focus more on during the demining operation. Then, of course, we have the demining operation. We want to remove the people from the area, but we always need to have deminers doing a very detailed analysis when it's absolutely required. And we are trying with this system to remove as much as possible the people from the area, but it's always necessary at this point at least. We also have a series of small robots that are able to excavate some mines. It could be various sizes. We have chosen one of the example on the screen here. You can excavate, you can neutralize the mine, or you can do some inspection when you have a threat that is already identified. And we also have large robots to be able to make sure that the area is completely freed from any suspicious threat by doing this. And so the key point of our solution is that all of these devices are integrated into one single system that can be operated by 1, 2, 3 or more operators with an embedded control station that can be put onto a container or onto an armored vehicle, which is very flexible and can be moved very easily. And any operator can take ownership of any satellite, UAVs, or robots at any time and can get the full understanding of what's going on at operational level at any time. So people can work as a team with the full level of information up to date, and it's very convenient and efficient compared to what is currently in use with this kind of operation. I think you can move to the next one.
No.
That's next one. So basically, we talked a bit on what's going on at local level, at operational level. We also have some advantages for the national scale level, where the administration wants to know where we are in terms of the progress of the demining operation. So our system makes it possible with all the data that we collect to collect everything in a consistent way in a single point of location. Every information coming from the surveys, from the robots, we collect all the data. Then we can compute the appropriate metrics that we work on with the authorities to understand prioritization score of each area, because the key point is to be able to focus the effort on where it's absolutely required. We have a lot of surface that is contaminated or potentially contaminated. The key point is to make sure that we spend the limited effort that we have on the best location so that we have the maximum efficiency. And it's possible to compute these metrics. We also can have an overview on where we are in terms of the progress, because it's very difficult, especially in Ukraine, to understand if this area has been already decontaminated or not. So with this system, we can just upload the information very easily to make sure that the administration is fully aware of where we are in terms of the progress. And then we have a lot of work done on the visualization part to make sure that the information is very easy to digest and to have a very good understanding so that the right decisions can be made. And then we start again the loop by collecting more data, computing the updated KPIs, and then closing the loop so that we enter into a very efficient progress. Next one, thank you. And at operational scale, as I said, so we have control stations. It's very easy to scale. We have done some demonstration already last year of part of the system. Actually, we've been very pragmatic in this approach because all the hardware that you see on the right is already hardware that is existing, that is already in use into NATO forces. For instance, the two robots on the bottom part are already in use in the French army, and we have added a layer above that to make sure that they can interact together. And the architecture of this layer is very easy to scale, so that we can have multiple robots controlled by multiple stations, and you can do very complex operations very easily from a single point of control, which is very, very efficient. So the control is made consistent, so we have not done a standard interface for all the drones. Each drone has got its own very specific and relevant interface, and we are able to make sure that any operator can take ownership of the control of any drone at the appropriate time, with, of course, some level of validation by the team leader, but it's possible to have a lot of flexibility on that. And what's key is we have defined an architecture that is able to update for everyone the information. For instance, if you have a UAV that is detecting a suspicious area, then everyone in the team is able to see the localization of the area. It is able to see some images when it's relevant, or some characterization of what this threat could be, so that for safety of the people, it's very important that as soon as we detect a danger, everyone is aware of what is at stake. Then we also have some messaging capabilities, so that people can interact between each other, and it's always a way to improve the coordination of the team, which is what we are looking for this system. Next one.
So in the global system, we need to use the best vectors to get information from the ground. So the initial idea was to use existent means that we can find on the market, but typically for UAVs, we could not find what we wanted on the market, so we decided to make a development. So for a good UAV, we need high autonomy and we need sensors. We decided that on the UAV, we would, for example, use a fixed-wing UAV to have high autonomy. And we decided to choose 3 different sensors. The first one is a photogrammetry for mapping. The second one is a thermal camera for getting the thermal contrast. And the third one, which is super important, is a magnetometer to detect magnetic signature of munition on the ground and under the ground. So I know that there are a lot of UAVs on the market at the moment, but one UAV combining those 3 sensors with high autonomy, it's still under development, I would say. The goal for this UAV is to cover very large superficie of land in less time-consuming way compared to team of deminers covering a land.
And about the robots, so we have a brand new robot that has been developed for the French army on the top, that is able to demine a large area at a rather high pace, that is not sensitive to anti-personnel mines, of course, that can also take neutralization of anti-tank mines to a certain extent. And also with this system approach, it enables the team to keep the maintenance of the unit as far as possible. For instance, if with the camera with the UAV there is a detection of an anti-tank mine, then it's better to tackle the mine with our deminers or with a robot, so that you preserve the lifetime of the big asset that you have with this machine. And with this system approach, it's very key at the end of the day to have an efficient operation by not like going with the robot and take all the anti-tank mine that you will find, and then spend a majority of the time into maintenance of this robot. So this is also an outcome of the discussions that we had between the industrials that we are and the deminers that Germany is, to like build some scenarios of operation to improve the safety and to improve the efficiency. Small robotics as well is key to be able to remove the people from the field as much as possible, and make sure that we increase the level of safety into this demining operation. So same thing here with the system. We can take the decision whether to send someone to tackle the threat or whether to send a UGV instead. Next one. Artificial intelligence, so this is key. This is really innovative, low TRL level at this stage, but it starts to be promising. So we do not recommend to use only artificial intelligence at this stage to tackle the threat, because of course you can have or false alarm or you can miss some threats, but you can detect things that is not possible to detect with the human eye. On the right side, when you use multispectral imaging, you are able to see in this picture, you don't see anything, and in this picture, we're using the infrared detection, then you are able to see suspicious area, and with some level of training of artificial intelligence combined with the training of the people behind the screen, still at this stage, you are able to identify large number, higher number of suspicious areas with this methodology. So this is very promising. We have integrated that into our toolbox from the know-how we have in France, and we would be very pleased to integrate more solutions into our toolbox, which is possible. And we've seen into today's session there will be some presentation about artificial intelligence and multispectral detection, and we have all the capabilities to integrate the best solutions into our toolbox, and we would be really pleased to do that. Also, like just simple artificial intelligence image processing can also detect movement of terrain, so that we can also identify some threats doing that. So that's very innovative and promising methodologies.
But technology development never work if you don't get experience from the user. So this is why we decided to integrate users' feedback in our project, and for a few reasons. Because first, we need to train AI with the knowledge from the users. So, for example, in my company, we have a huge data base about munitions from Second World War to recent conflicts. And this database will be sent to the IA as a data set and train the algorithm to recognize the type of munition. Of course, the user also has some specification about interfaces, so we need something simple to be deployed very fast, and something that is understandable and not only coming from the brain of engineers. And at last, a system that take into account the constraints on the field. So we're talking about weather, we're talking about temperature that can be very high in summer, very low in winter, and still the solution needs to work in any condition. So this is why in my company, we are a mine clearance company. We employ only EOD military people, and we have deployed teams all over the world. So we want to use this knowledge to build the best solution. Just a final word to sum up. So what we propose today is a system that will use and exploit the latest technologies existing today or under development, such as UAVs, UGVs, AI, and deminers experience, because we want a system that increases the efficiency and protect life of deminers on the field. So we invite you all to take part of this mine revolution, and we hope to discover new technologies today, and hopefully, if we win, we will deploy our system soon on the field. Thank you very much, and please, if you have questions, we are here.
Thank you very much. I invite you to say not the if we win, but when we win. Okay, good.
Yes.
Jury members, do you have any questions? I could bring the mic to you. Oh, you have one? Anyone?
Thank you very much for your presentation and innovation. I have one question. May you elaborate about the ability to operate at the area where there is no GPS signal? Thank you very much.
Yeah. So it's good because I'm part of Exile. Exile is the merge of ECA Group, who is doing robots, and AXBlue, who is doing inertial navigation systems, gyro-compassing navigation systems that are able to work without GNSS. So we do have the ability to put on the robots inertial navigation systems that are able to find north using only the Earth's rotation, and able to navigate to a certain extent with a precision of a few tenths of % of the traveled distance. So this is possible to navigate on the ground with that. And on the drone size, we also have an inertial navigation system that is very small. It's called the UMIX. It's a 1.5 kilogram, and it can gyro compass and also navigate in the GNSS denied environment. I think the answer to your question is inertial navigation systems that are really improving performance right now.
Got it. Thank you. Good presentation. Can you elaborate a little bit on the maturity of the system overall? Where is it right now, and what will it take to move it forward fairly quickly?
Yeah, so last May, we've done a year ago, we've done a demonstration to the French forces into a challenge, an innovation challenge called COHOMA, where we have put together a system with some aerial vehicles and robots, and we were able to control all the functions of the robots and the drones from the remote location in practice. So all the robots are developed, the systems is developed. What is missing right now is the full development on the national scale level for the KPI that is coming up. So we are looking for partnerships for that to be able to move quickly towards a very effective solution. But we have been very pragmatic into this approach, taking hardware that is already existing and putting everything together quickly.
And it does work. Okay. And also on the maybe just on the UAV, we also defined the list of specifications we want to see on the UAV. We have tested the different sensors, but still we need to fully integrate the gimbal on the UAV. So that's also the work we need to do.
Major Malashus, enjoyed your presentation. Thank you. I have a couple of questions regarding the UAV working height, the altitude, and what one of the sensors is a magnetometer. What is the approximate depth to
So
find
for
out
the magnetometer,
bombs
yeah.
or whatever?
So
Thank you.
it's a very good question. So for mapping, you need to be at 100 meter or even between 50 meter and 100 meter. That's for mapping. For observation, could be at 50 meter. For magnetometer, you need to be very close to the ground, so at 1 meter. So it's very difficult for UAVs to navigate so close to the ground. So we use a telemeter system to make sure to control the altitude. And in terms of depth, the magnetometer is more for on-ground ammunition, and when you go deeper than 10, 20 centimeters, it starts to be a little bit more tough to detect.
Yeah, but the goal is to go to 60 centimeters depth.
Yeah.
Thank you for your presentation.
Okay. So, can you elaborate how will you operate in a urban environment for detection and your disposal system?
In a European environment, you mean when you think about the standardization or all the standards for NATO standards, you mean, or?
No. Urban environment, so you know that the combat takes place also of course, in cities, and so how do you intend to use your system in this type of environment?
Yeah, so in terms of frequencies for communication, so there are some specific configuration that we can apply to the system to comply with the regulation of each country where we use the system. And after, our toolbox is really versatile and adaptable. So it depends on the group of deminer to look for what is the appropriate tool to use or not, depending on the environment. So I don't know if I answer correctly to your question. But any hardware that is already possible to use in a city environment or in a jammed environment will continue to work the same way as it works today. And with the system approach, you benefit for more than that.
And if I can just add something, we in the demining world, the way we work today, we follow the international mine action standards. So these are the international standards that define the way to demine in every country in the world. So that's the standards published by the United Nations. So we use those standards at least to define how the operator will work, the different phase and the different methodology. So those standards, they are already existing, and this is how we try to always work when we go on a mission.
But I would be very pleased to have a discussion with you on the coffee break, because I think we missed part of your question in the understanding.
So a question would be on the AI side, where are the training sets coming from, particularly the field-related ones, and how do you accommodate sort of ongoing adaptation to changes as folks change their tactics on the other side?
Mm-hmm. Yeah, that's a very good question, actually. So in my company, we are about 70 people, 70, let's say 60 EODs, ex-military. So we have built this database during a mission that they went to, their knowledge, photos that they took. We also share this database with the French civil security, composed of deminers as well. And everything, years after years, we built it. And today we are also very active on social network to get information from Ukraine. So as you know, there are a lot of videos and images circulating. And so every day we have a watch on the social media to get information on ammunition. So I would say it's mostly based on knowledge and experience, and also from other database in France that we had access to.
That's the operational answer. which is great to have the first image. And then to the industrial side, we have specific algorithms to build a training set of images, because one image from one ammunition is of course not enough to train AI. So we have some specific algorithm to take one image and build a training set for that is applicable for the AI, and then we can improve our algorithm for that. But it's really key to have the right images as an input of this.
Yeah.
And along those lines, thinking on the humanitarian side, where you have stuff that's remnant from a long time ago, so you don't have the same ground disruption patterns, how do you accommodate that?
I'm not sure I got the question.
Oh, I'd imagine you were talking about some of the views down. You've got obviously the magnetic signature and things like that, but you also have sort of disruption patterns in the terrain that you pick up.
Yeah.
When we look at in the humanitarian area, where you have something like Cambodia, Laos, or someplace like that, where it's been there for a number of years, how does your system accommodate for that?
This is part of the human experience of the people that are already used to use this magnetic sensor on the field. I mean, AI is coming here to help decision and digest a huge number of data, but at the end of the day, at this stage, we still need the eye of the specialists that is able to recognize, we don't know really understand how, like false alarms and real threats. Yeah.
Thank you very much. I'm watching the time, of course. Thanks for opening the stage. It was, it is always harder to be, the first ones to open. So all the best luck, fingers crossed for your pitch. Let's see at the end of the day if you succeeded. Thank you very much. Round of applause. Thank you. Okay, let me do some job here. I think some of the jury members don't see the screen because of this part. So I guess that's a lot better. So I invite the team. So in the jury list, this will be the team number 3. AGAI DRM, Advanced Aerial Mine Detection System, team from Lithuania. Yes, please. The stage is yours. You can use this mic. There's a slider on the top of that box. Okay?
Hello. Just 1 second. Yeah, so this is the name of a solution, so to say, following the application form, AAMDS, and it stands for Advanced Aerial Mine Detection System. Basically, I looked at this with my team as an idea, so I'll try to explain as clearly as possible which parts we are good at, we've done, we have currently, and what do we plan for, because this is all in one in this presentation. My name is Ignas Daugela. I am from Antanas Gustaitis Aviation Institute, therefore the AGAI, we'll get to that in a minute. And I represent not an actual business, but department, the faculty of Vilnius Tech or Vilnius Gediminas Technical University. Yes, so about us, our faculty now has 30 years of experience. It all started as glider creators, working with general aviation. We have pilots, we have flight controllers. As a study, as a specialists, we do a bunch of related stuff to the various aviation, mechanics, and aeronautics. And basically, this is the place where some known companies started. To name a few, Nanoavionics. Actually, one of creators was our student, later worker, and still works there with its next startup called Astrolite. I hope you know it. And other things like manned defense systems and etc. So to cut it short, let's move on to the topic. So DRM is a team name, so we kind of gather a bunch of specialists for one common task. So detection, recognition, and mapping. So today I'll jump in to the topic of mines or unexploded ordnances. Our approach is, starts from aerial, from aviation, from aerial stuff, and I would like to emphasize the IT part because we're good at integrations and providing the code base for it also. My view to this topic is also that every person counts, so therefore we have a plan for good efficiency. I'll tell you where we start now. And I think that for all of the other finalists, I would like to mention again that every solution should help. So the more better solutions, the more good solutions we'll have, the better for the world and the future. So this is part of a team, the younger ones. They are very efficient at prototyping, and that's what we do. We write scientific articles, we create prototypes, and the loop goes on. We also offer participations and working together with the business. So backgrounds are different. Aerodynamics, general aviation, piloting, UAVs, and mechanical engineers, avionics. Also we have innovations in 3D printing and etc. So basically my part is remote sensing and mapping. That's my background, and we have teamed up with persons from geology, archaeology, and that helped us because the problem is, as I see it, at least I found it on a report from 2023, landmine report, or how it's called. So we have stockpiles of 50 million mines, and we have states or countries in the whole world, like 60 of them. And we had many casualties, almost 5,000, out of which 1,500 was killed, and civilians accounted for majority of it, and part of it, almost half of it, was kids. So that was our scope to do humanitarian demining, and we started in 2022 with our first prototype. So our idea here is to improve the process as much as possible, so we outlined the plan for technology to evolve. We started with a magnetometer, high frequency, high sensitivity, sorry, and it can be tweaked, so we try to find metal things, and it works pretty well. I'll get into that in a second. And we aim to add GPR so that we could estimate objects of different materials underground. We also already are researching and developing on thermal and visible spectrum cameras to involve into that. And we have a concept, only concept. We're not strong at this. We haven't started exercising, but we have a concept of explosive charges to neutralize the mines, so to complete the idea. Okay, so now I'm a pictures guy, so I'll try to explain visually. I will run through it and we'll get to your questions. So first things first, how do we visualize it? We take a map, we create it with a photogrammetry of, you see here drones, right? So you see options of DJI, and I will show you other options, but we started with it. It was like a working horse. It flies long and it various conditions. Therefore, we prototyped on it. But I would like to emphasize and make it a strong point that we are from Aviation Institute, and we, not every year, but we create a new drones like fixed wing, multi-rotor, and etc. So you see a solution. It looks like that. It flies. I will show you how it flies. But this is what do we have. We developed for several winters, not super fast process, but we developed a payload, how to attach it to be able to fly, how to minimize the interference of electrical parts and other things. So here actually magnetometer, auxiliary things to make the readings precisely put on a map, and you see a drone as a vehicle. So next thing, yeah, sorry for that. So firstly we take RGB and other layers of pictures. We create a 3D map. We put it into the system so it knows rough estimation of a surface. So we then follow closely to the surface with magnetometer as it moved. Just next I just moved GPR. It's a UAV solution for that, and then we also add so to say thermal camera in combination with it, and the last part is neutralization. Another thing is today I have estimates for M600 just because it's a sextacopter. It has more stability. It's not the best drone for it, but I placed it as a reference because we can switch the payloads easily for that. And also, if we would to scale or provide to other markets, we digged into that and checked like perimeter 4 and other models as replacements instead of that. So to speak, to be more compliant. We can pretty fast switch to other drones because we created our custom payloads and our custom software bits, let's say. So yeah, but for the recognition and mapping part, for the cameras, we propose next year, for example, at least on our roadmap, our own created Solar. We call it Solar. It's a version 4. It's created by the faculty, like masters and staff members and researchers together. So it runs for at least 6 hours in Lithuanian summer. We tried it 2 years ago. We aim to attach other equipment on the other side of the wings where you cannot see, and here is aerodynamically well-placed solar panels to mix and match energy sources. And we also have an algorithm to follow cumulus clouds in order to find thermal flows and save energy, so be in air longer. So basically, that part would be for the thermal, and I'll explain later. I wanted to do a compilation of fails, as it is popular on YouTube, but I looked at it and it was too long and inefficient. So here are some things to see that we developed for a long time and optimized it. So we had at least 4 different versions of payloads. This is how we test it. We place metal things. We know how they look like, how much they weigh. We use professional surveying equipment to take accurate reading of its location, and then we do our stuff. We iterate, and the day ends. So this was, I don't know, 2022 winter. So basically, I didn't invent much here in terms of where to fly, what to do, but we have a systematic approach and looked at each of the things. Okay, so visualizations. This is how it looks like the actual flight, like a drone from a drone. The line is just a representation of trajectory. It actually covers more, and we can tweak the magnetometer and other sensors so it reaches further away, but a little less resolution or less accuracy. And then we cross-check it in a data flow, in a time series, and try to mark it if it has enough confidence. So this is for a magnetometer part as well as for other parts later. And what we try to do is to create sort of a statistics and sort of information for a dashboard for IT system. So here you see our ADS. This is just a mock-up, right? But because it's from the sky. So we give a field an ID. We count the mines. We also, from gather data, create area, and also we try to estimate if there are lines and how many lines, and later if there are more mines we also try to estimate average density between them. Okay, so IT system, I will not get into that much, but the idea is to have layers as well as overall look. So layers consists of spectral scans, GPR and magnetic scans. Of course, first layer is RGB for overview of the whole place and to make tasks and to make decisions and to scout, to prepare a mission plan. But we think that it would be nice to have a prediction layer, which is based on books and on probabilities, and will learn over time. So, for example, if you see this mine, most likely area is this big, but this is only an estimation. And if you have these mines like this, most probably it will look like that, and you will encounter several other mines like that. So we kind of create a database of relationships ourselves as a humans, let's say, and we program it into the code which receives sensor data. This is the idea. This is for the future, for a near future. So this is overall. You create tasks, you give it to somebody, and they execute it. So mission planning, this is the actual software. We customized existing solution for our needs. Okay, so this is not new, but we're well aware, and we are able to control everything here. So you create your area. What we needed for magnetometer part was the bigger density, ability to go lower, to follow terrain, and etc. So we have it all in here. So you can control the density, at least from before. In the next venture, in the next version, we plan to do varying density. So you make it less dense, and as soon as it encounters something after several seconds of averaging and estimation, it creates new plans. So some parts are denser and some are sparser. And next, this is partly a mock-up, but we have this. We use it based on a DJI SDK for the moment to make a rapid development. So you upload that mission plan. You can also dynamically change it, and you start the mission. And this is we control the timing, the estimation. We see actually the data and etc. In real time, raw data that is later used for better predictions. So technical details for this day, and I estimated for one drone just for convenience. So basically RGB could be covered 1 square kilometer in more than half an hour with 1.5 centimeter ground sampling distance, and on average without extra control points like 4 centimeters root mean square error. Magnetometer we aim to match with thermal infrared because it has lower resolution, because we can easily control the aiming of it, and then depending on the needs and what you actually find while flying, we cover from 1.5 to 15,000 square meters in almost a half an hour. This is from real flights because we already did some testing. And GPR we estimate this much. So idea is to have like 3 drones and 3 payloads. One is fast and covers huge areas, and later we replace it with MAIL, the medium altitude long endurance drone of our making, and for cameras, and for magnetometer and GPR we can scale from that. We can have more drones, less drones, they divide the plan, and etc. And that all the technologies are already available to us, and some are customized by us, some are created by us. So for neutralization part, we just estimated the flying trajectory because conditions vary. I will get into that in a minute. And so basically our approach is user-based, so it has to be some deliverables at the moment, like raw data, then some layers, as I showed you in a mock-up of a IT system. We process data. For each sensor, we do some sort of processing, and then we feed it into a decision-making algorithm. So it votes for a confidence, and the humans are controlling what AI is seeing. So it will be a mix of math things, our decisions, like programmed logic and AI agents, so to say. So this is our idea. This is from the test. We tried with metally things, various things, and I would like to say that all metally things were discovered, found, and on the map, let's say. And of course, at the moment, we don't have a solution for plastic mines, but we already know a clear path. And you can see on the right that it also finds other things, but I cross-checked it like these are the corners. One is a handrail, one is piping, and another is different piping. I cross-checked it with a topographic map and known underground things. So, but this is for magnetometer part, and this is from our experiments and real data. This is what we are researching. So there are many algorithms to detect surface mines and plastic mines and etc. Another thing to mention is that we would like to add very fast the IR camera, GPR, then iterate with the payload, so it would be plug-and-play solutions. And at the end of a line, we try to replace the vehicles, and in between, we iterate the algorithms and add the actual trained AI. We would like to not to rush into it because there are other ways to start, and we would like to make it on the down the line to appear later. This is how do we make a decision. So some instruments vote for the surface, and some vote for the underground, and some are interconnected. GPR, not much to see here, but this is an example of what can be implemented here as a layer. This is a vertical cut, and you see there 4 objects. We've seen the research, this is not ours picture, but we've seen research where they put it all together, but it's hard to control the interference, so we will not do that. We will split payloads differently. And yeah, so our concept. Our concept is to have small detonators. They fly with one of the payloads. You have it there placed based on a coordinates, based on a confidence, and you have a like remote controller with IDs with many buttons, and you are free to choose whenever and what to do with them, like to explode or just to you have it as a marker, because it will have GPS, it will have a battery for at least 2 days, maybe sometimes for weeks, so it will continue showing up on a system. And yeah, so basically we put it in a rotating drum. Yeah, sorry. So we have a rotating drum concept. It's finished, but concept. And we have like 6 of these in each, like 100 for the things to explode, 100 for equipment grams. And we have 2 drums in one payload for 1 drone. So basically, and 1 drone on average would fly 25 almost kilometers. So depending on the conditions and how many mines you found, we can mark them all with improved markers, not these red flags, let's say. And to finish up, I tried to compare our team's work with others, what I could find on the internet and publicly available. So first one is not a drone solution. It's based on actual aircraft, so different implementation and costs and etc. Next thing is our Goblin. So our is easier to deploy, not a huge thing with a mortar. And I only seen like mine by mine, and they were placed on the surface. So I'm thinking ours is more deployable, and also they don't have subsurface, beneath surface data, as I understand, and many other solutions that are naval only. Ours can fly over Earth and over ground, over water. So our is safe as others, but efficient and adaptable. So to wrap it up, we are combining mathematical algorithms, human logic, and AI, so data fusion doesn't become data confusion, as we heard yesterday, or information doesn't become misinformation. Yes, physics are the same, therefore many of us will suggest you the same sensors, but there is no one golden instrument, so the thing is to combine sensors, human logic, and AI at once. And this is altering capability, And I think I would like to stress out at the end that we would like to have strategic partners for long term and investing in us. So it's not just about technology, it's about saving lives, restoring safe, usable land to communities affected by actual landmines. So I try to be as concise as I can. I think you still have some questions because unlike our AI human communication is not quite ready for the final release version. I'm ready for your questions. Thank you.
Thank you very much for the presentation. Thank you. Round of applause. Dear jury members, your questions, please.
I'm always happy to start. Nicely done. Clearly you're integrating a lot of things. Can you identify one or two very specific innovations that only you have?
I would say a systematic approach for all of the things. And I don't know, I think it's pretty innovative solution to place like this the magnetometer to counter the interferences and etc. Not to be disturbing the flight and etc. So I would say magnetometer replacement payload, maybe it's not the first overall, but I think it's pretty innovative. And overall, we digged into that. Many people fought for an hours, brain against the wall, and we banged, and this is our systematic approach.
Okay.
Mm-hmm. Sort of a related question. This is clearly a domain where false negatives are bad. Can you get a sense yet how accurate your mapping will be?
Yeah, so I would be lying to state that this or next year it would be 100%. Yeah, we are aiming at 95%, I would say, but at the moment we only have experience with medley mines, and we have research data, examples, data sets for cameras of visuals and thermals. So yeah, we will try to mix and match, and we will provide you with a sort of a confidence level that we aim to be about 95 and above, rising. But our idea is to have our restrictions. So we say that this is the field that, not this field, maybe this is an area, this is a surface that we are good at, and this is a situation we are good at, so we are confident here, and let's work as experiment together on this situation.
Okay, thank you. Yes, please.
Yeah, thank you very much for your detailed presentation. One question on interoperability. How do you envision to exchange data with other systems? Is it foreseen already, or is it something you still have to look into?
Thank you for your question. If I understand correctly, you mean with other operators of other systems, other tasks?
Exactly.
Yeah, so we were hoping like military personnel would recommend us what they exactly want to do, but we have a couple of people working for a long time to procuring for army in Lithuania and elsewhere with drone solutions. So we were thinking LoRa or other meshed network solutions, but we foreseen it, but theoretically only. So we were thinking more about data integration actually, and visualization and UI and personnel rather than which technology to use to transfer the data.
Thank you. Yes, please.
Okay, so you're detecting and identifying some things there. Are you going down to the classification level, or you're saying, what am I dealing with here?
Yeah, we have a technical plan for that. Yeah, it would take next year at our current pace, but we aim to use spectral signatures from magnetometer, fused from sensors. We have at least 2 directions how to interact between 4 types of sensors. And we will dig into that. As I mentioned, we don't want to place everything on agent or anything or everything based on our logic. We would like to mix and match.
Mm-hmm. Okay. Some more questions, please.
Could you elaborate a little bit on the type of explosive charge you will use for the disposal and neutralization of the device in the field?
Oh, I'm not good at it. Can I show my presentation again? And actually, this is just a concept we could change, but
just a second.
Oh, I'll try to not that fast. So basically, there was written explosive type. That's one thing for sure. We tried to estimate for now the weight of it actually, and we came up with a plan that it shouldn't be like exploding on impact or etc. But this is estimation from well-educated guess by my colleague, who is also in a Riflemen's Association member. So yeah, so basically a detonator extending leg, so it doesn't roll out, so we can be as precise as possible. We mark it for a long time. We have a GPS because it's pretty cost effective.
Okay.
Yeah, and then you have the buttons, you have IDs. Each release from the drum has the IDs connected to the remote controller. That is the idea.
Good, thank you. And yes, please.
Okay, thank you for your good ideas. And my question is, have you considered how might impact explosives to your drone flying at low altitude and hanging magnetometer? Have you considered how it could impact or some UAV flying at low altitude?
Do you mean in this part or in sensing part?
In general.
In general, yes, we thought about that, and the detonator part is like, I forgot, 40 meters high. We will find the sweet spot of altitude, but for magnetometer it will be pretty low, some decimeter level, literally like 10 to 20 centimeters above ground, something like that. And I don't know, I consulted as much as possible openly with others from Lithuanian army and others, so I tried to grasp the concept that is we don't touch it first of all, and another thing, we are small enough, and at the end part we don't have any electronics, it's the antenna only, so it will not create some forces or fields that would trigger something. And we will not touch it for sure. We will improve over time our terrain tracking capability that for a moment we outsource by our solutions.
Yes. One more question. Yes.
Last question. So just so I have this in my head, you identify a field, you fly the drone over the field with a sensor, you come back, you fly again with a different sensor, come back with a different sensor. How much data analysis is necessary, and how long will it take from the time you start to the time you have an actual finalized map?
Thank you, I forgot that part. We aim at 1 hour turnaround time, so you have at least 3 drones, or you can have 6, 9, 12, and you have 3 types of payload, or you can have 9 or 10 or 12. And there were like clear digits, like 4 times faster or slower between payloads. So turnaround is 1 hour. For magnetometer part, ground penetrating radar, it will be almost real time. But for the cameras detection and these layers and prediction, it will be slower later. It will be coming from the servers back. So we think that the slowest turnaround time in case of RGB, high resolution, small things on the ground, we think that if the flight is half an hour and you switch sensors, so after latest 1 hour, you should have data for at least 1 hectare, something like that. We try to optimize into that. It sometimes will be faster.
Thank you very much. Thank you for your presentation. Again, round of applause.
Thank you.
Thanks a lot. Good luck. And then I invite next team, the jury members. This will be team number 4 on your list. Actually, it's a 3rd team here on the stage, a RAS LAB DeNEMIS, detection and neutralization of explosives using multi-robot and intelligent systems team from Belgium. I move a little bit just because of the transmission. Yep, thank you.
Good morning, everyone. Good morning, dear members of the jury. My name is Mario Malizia, and I'm here today as a research engineer working at the Royal Military Academy of Belgium under the Robotics and Autonomous System Unit. Today I'm here on behalf of all my other colleagues who unfortunately could not attend due to an overlap in their schedule. So I will delve straight into the problem. Today, human intervention in landmine, as we already been speaking also with the other presentation, is low, dangerous, and is also resource intensive most of the times. A lot of humans' lives are lost in the field, and this is becoming very risky, not only for the personnel involved into the demining actions, but also for the people living on the field. According to this statement from GlobSec, it will take more than 750 years with the current technology to remove effectively all the mines on, from Ukraine. There is hence an urgent need of robotization and trying to automate as much as possible the process these days. I would like just to leverage on a couple of KPIs that we had put in our presentation. In order to do that, we have foreseen investments in technology that can speed up the mining phase, as well as the usage of AI-powered robotic systems that have been well addressed today by the previous contestants. The usage of AI in robotic system must not be abused, but must be used in order to develop things that human cannot do. Human, by definition, are suited to working hours. Think about people that work in the office, they have limited working times. Machines, apart from the end of life, they have an infinite working time, so they can keep on working on the field and doing the human job, but always we're kicking the human in the loop. And last but not least, this increased automation could significantly reduce damages. Damages not only to the population involved, but also to the people working on the field for the mining. So our first idea would be, let's deploy some robots on the field and let's try to remove correctly the landmines. And according to our consideration, we would like to spend some words on the usage of UGV and on the usage of UAV prior of presenting you our solution. So let's consider a generic UGV that we have set up with a LiDAR, camera, and a GPS signal, for instance. So the LiDAR, for those who are not familiar with the topic, is a laser sensor, very, very short. We produce an output in 3 dimensions, X, Y, Z, commonly known as point cloud. Then there is the camera, we addressed, widely been addressed before, which produces an output of an RGB image and a GPS signal. So I will take some estimations and some images from a well-known data set in the research field, which the field I'm working at, which is RAS 3D. And if we want to detect objects at far distances, there are some problems with point cloud and these issues known as the sparsity issues that we cannot correctly detect what is very far in the field. The same problem actually happens with the images, and in particular we do have a lack of sharpness in distances. So the farther we go into the image itself, the more we have a deterioration of the pixel, which doesn't allow us to have a proper and correct view of what's in the image itself. This reflects most of the times in raw image processing with common AI process algorithms, for instance, the segmentation one. Unless we do undergo a lot of processing into the original image, a raw output process may lead us with some misunderstanding of the image itself. On the UAV side instead, because the problem to overcome the land one would be, okay, let's deploy some UAV and let's try to map. But only for our side and on our previous project that we have worked on, we have some limited constraints just on the UAVs, which were mainly of sensors limitation and data quality, since we do have to deal with a lot of sensors maybe mounted on the drones, and with environmental factors that can lead to short flight hours or short flight times that can deteriorate the performance of the detection based on the UAVs itself, as well as some operational constraints, which might be the battery associated with the drones, or some problems with obstacles themselves, which might be high trees or high vegetation in the area. And this is why today we have decided to combine in our innovative concept the land usage, so the land component, with the aerial component, introducing DeNEMIS. Our approach is based on 4 different phases. In the first phase, the first of recognition, we would like to have a short flight on the area. So the use case in this case is that we already have an a priori knowledge on where the mines could be. So we do have our first phase of recognition. The information gathered in the recognition phase are processed in the processing phase. The processing phase is used for 2 things: to have a clear route on where to deploy the land component, in this case composed of UGVs, and to give some useful information to the deminers, because our approach will always like to leave the human in the loop, because that complex tasks require people always in the loop. And the confirmation phase, which is the phase where we would like to deploy the UGVs to adjust the map previously deployed by the aerial component in order to specify and clarify if there have been some misdetection, or if there have been some threat detection in terms that some points have been weighted more in terms of, do we have to act more on this point rather than the other one? And last but not least, the neutralization phase. And I would like to introduce also our approach behind this. The approach behind DeNEMIS, we have foreseen an approach of co-design and co-development. This is very important in order to keep people in the loop. People kept in the loop can be military personnel, military end users, as well as stakeholders. This is why our goal, based on the previous expertise of previous European project and previous contribution with our components, because Royal Military Academy is part of the Belgian defense, to develop our solutions in cooperation with the Belgian EOD group and other people and other military working inside the Belgian defense, acting as experts, as well as stakeholders. I will go straight to the point, and I will try to explain you our concept that I'm here presented today. But before, I would like to stress the fact of keeping people involved in the loop. This allows a priori requirements fulfilled, and to the validation and closed loop. So we start from the a priori requirements, we try to develop something, we go to the end user thanks to field trials that we may have in cooperation with them, and then we close the loop and we try to adjust until we try to find an optimal or suboptimal solution to the problem. I will go straight to the point, and I will start from the recognition phase. So we have foreseen an UAV flying equipped with a set of sensors, which doesn't mean that it needs to be used altogether, but means to be used according to their availability. So there has been some question before, leveraging on the GPS usability. We might foreseen, of course, a circumscript scenario to work, but there might be availability as may not be availability of the GPS itself. So based on an a priori knowledge that the area that we want to operate with might be infested, we do deploy our UAV to have a fast survey of the area. So based on the camera flight, for example, we might be able to detect, we are able to detect some mines, land mines on the field, and to give this information to the C2 station where the operators operate. This allows us to have a terrain analysis, as well as to start to think on how to process the UGV route that has to be deployed on the UGV themselves. So just for instance, we have developed some renders to have the process more smooth in order to let everyone understand. We do have the RGB raw image. The RGB raw image of the UAV flying on the field is processed with the other sensors that I mentioned before in let's say the brain of DeNEMIS, which involves the usage of AI algorithms. So we have the RGB raw image and the GPS data according to the availability, which doesn't mean to be a fluent GPS signal, but it can also be intermittent, and the aerial point cloud coming from the drone. these data are processed in a way that is not understandable in most of the cases at the human eye immediately. And this is why we need to process our data in order to let it be comprehensible to the final end user, which are the troops on the C2 station and C2 postcards. This is why in the processing phase, which is the phase following the first one, we try to let the operator situational awareness rise thanks to the positioning of waypoints according to the previous analysis that has been conducted through the UAV usage. In particular, as you can see, I've put a small image of a C2 station and a situational awareness thanks to our UI interface, where we plan to put waypoints of the suspected infested map with different colors. These colors leverage on the probability of detection of the first phase given by the UAV analysis. And of course, the red one is associated with a more heavy threat and a high probability detected threat, whereas the green one is detected with a low probability detected threat. In the next phase, always in the processing interface, our aim is to develop the route in order to deploy the UGVs. So as I was mentioning, the color follows the detection of accuracy, and we do deploy our threat-based planner. A planner is something that tells the UGV where to go. So we have the planning of the route of the UGVs, a global plan of the route of the UGVs, to tell them in a swarm, let's base our path on optimality, so an optimal algorithm, and let's go in different direction in order to verify if the information given by the UAV is correct or not. And so we do deploy the global plan on the robots, on the UGVs. This follows the confirmation phase. In the confirmation phase, we do deploy the UGV swarm. So this is an example taken from one of our previous collaboration into a European project, where you can see the development of the UGV swarms on the field. And these are waypoint navigation, so they're able to navigate according to the waypoints given. In this specific example on the left, the waypoints were given by the operator, but they arrive at the waypoint autonomously. But the waypoints can be given by an algorithm, so it can be define a map a priori, and they can follow the waypoints. So the global map is deployed, and thanks to the equipment of the sensor suite on the UGV, we are able to change the priorities on the map that has been previously deployed by the UAVs with some processing. So I've left an example on the left where seeing a generic UGVs with different sensors according to their availability, there might be or not be a change of priority if there has been a low detection from the aerial survey, or a removal, like a false detection, if there has been something badly detected from the aerial survey and that needs to be changed according to priority. At the end of the third phase, we foreseen a map that is well enough to be deployed into the neutralization phase. In the neutralization phase, we leverage on the capability of the manipulation. So we are testing at the moment some removal, mine removal techniques on one of our UGVs. This is one of the UGVs used in research. It is a clear path automation ASCII robot is called, with a manipulator on top, which is state-of-the-art in research. And we want, as I mentioned before, always to keep the operator in the loop. So we always want to have an operator supervision in the final demining phase. This is why we have an operator on the C2's postcard that might be or might not be asked for action. And we have foreseen a coordination between the arm and the platform in order to approach the landmines that have been detected thanks to the two previous phases. So with the initial survey phase and with the confirmation phase after the processing. So the two pipelines that we have foreseen are, for instance, given the operator supervision, the UI that I've introduced before does not give any supervision alert. This might happen in case of some very easy mines to remove from the field, like very small objects that have been detected. And we would like to go to a phase of autonomous disposal so that the manipulator itself is able to approach the object in order to dismount it. The second phase, and this is why I've mentioned that we will always like to keep the operator in the loop, is the phase of semi-autonomous disposal. So the operator receives from the interface a supervision alert. The supervision alert triggers the teleoperation mechanism, and the teleoperation mechanism tells the operator to intervene and hence to coordinate the platform movement in order to remove. And then we have the assisted disposal. This pipeline and also the phase that I've introduced before is different because we don't send the UGVs on the field directly, but we send the UGVs a priori with an information in order to let them already have an information and a situational awareness of the field itself. In some particular case, we have foreseen a VR feedback, which allows us to have a feedback, a more situational awareness feedback for the operator, because sometimes the operation itself in teleoperation is very difficult. We had some feedbacks, and those feedbacks always rely most of the times on 2D images, and having a feeling of the depth is very difficult from 2D images, and this is why we would like to have some experiments with virtual reality, having the possibility to have a 3D understanding of what's going on the UGV robot. We have also tried to think about some added values that this solution might bring to NATO. First of all, a strategic advantage. So this will lead to proactive threat mitigation, and under our point of view, to an improved efficiency. So we know a priori that an area is infested. Of course, there are some areas that still need the human intervention, but some areas where we already know that a priori there is a landmine presence, there might be our solution deployed that is useful to subtract some operational time to the troops involved in the field. The concept of scalability and adaptability, the tool I present is versatile, which means that we should not stick only with the sensor suite that I have just presented. We can also introduce some different sensors on the field, on the robots themselves, as well as some flexible deployment in terms of number of UGV swarm. The most we have deployed so far is 3 UGV swarm in a European project, but it might be scalable, and we might involve other kinds of UGVs as well as other higher numbers of UGV on the fields. And last but not least, the operational efficiency. As I was mentioning before, there is a resource optimization, since we might have some troops involved in higher priority demining operations involving real human in the loop, whereas this solution can be deployed in parallel in other areas where there is less requirement of the supervisor. I would like to spend also some words on who we are. We are the Robotics and Autonomous System Units of the Royal Military Academy of Belgium, and we have gained decades in the field, not only of land, but also of naval and aerial. And this expertise has leveraged on several projects that have been EU funded, so we are involved in different consortia of different EU funded projects. Not only related specifically to the topic of mine detections, but to other different defense-related projects, and also from Belgian defense-funded project on the subject. So we are involved in Belgian defense-funded project and European project. I left the QR code here. And this is today our solution that we have presented, and I would like to thank you very much, and thank you also on behalf of other of my colleagues who couldn't be there today. And we are thrilled and very happy to be in the finalists of the pitch day of the NATO Innovation Challenge, and we are always open to collaboration. So I'm here on behalf of all my team to discuss for cooperation with research or with research and academia or with final end users during the coffee break. And thank you very much for your time today and your attention.
Thank you very much. Thank you for the pitch. Okay, now time for questions. Dear jury members. Yes, please.
Yes, thank you for your presentation. Can you give us some example about the interest of artificial intelligence in the processing phase? Thank you.
Yes. So the idea that we have, I will spend also some word maybe on the network because it's involved in the AI process. We have done some tests at 150 meters with some antennas, so knowing a priori the place, we have 150 meters of line of sight. And regarding the question, your question for the AI processing, we had some inbound processing, so on board of the UGVs themselves, based on GPU of the UGVs that are deployed with NVIDIA GPUs, classic NVIDIA GPUs on the UGVs themselves, that can adjust, and the process itself is based on fusing the 2D information with the 3D information. So we would like to fuse the pixel of, we have fused the pixel of the camera with the 3D information coming from the LiDAR in order to overlap the 2D with the 3Ds together. And this information is transmitted via the network through synthetic data. The synthetic data is then either processed into servers according to the availability of the network itself, or processed locally most of the times and overlapped with the aerial server to fine-tune the final map that has to be deployed on the UGV.
Thank you. Next question. Yes.
Thank you for your presentation. It was really concise and nice.
Thanks.
I have a couple of questions. One question is, did you consider mines with magnetic fuses while deploying your UGVs?
You mean to try to involve also sensors with magnetic detection inside, or?
That mines can explode while your UGV is coming.
Okay, so the aim of involving in the loop the UAV, the very first phase, is to avoid this, which means that I've put some remarks on the LiDARs and cameras operating at very, very, very far distances might have some misdetection. So there is a need of going very close with the UGV itself. Going close doesn't mean going at centimeters. We might go at 1, 2, 3 meters and having the possibility of having information staying at 1, 2, 3 meters behind the object itself. And this allows us to operate as a safety distance with the UGV itself. Because the concept is we have an information a priori based on the survey from the aerial, and we are able to stay at a certain distance from the threat, trying to mitigate the risk of explosive of the mine itself.
Okay.
Thank you. And the other question is, what is the distance between UGV and operator?
Okay. So as I was saying before, we have done some trials onto some European projects, and we have used some antennas, common antenna Wi-Fi extenders, and we had achieved some 150 meters lane of sight. So this is the solution. But of course, we are here to cooperate, and we are open to extend the solution and maybe to find some scalability of the network issue that we might overcome with.
Okay, thank you.
Hello. What is the depth of the LiDAR into the ground that I'm interested in?
Okay. We have, specific to the ground, but I will mention also the air. We have done some tests with several LiDARs. We have, for instance, solid-state LiDARs, mechanical LiDARs, so the rotating ones. We, on the air, 40 to 50 meters, whereas on the ground we have achieved up to 50 meters and 40 meters of view with the LiDAR itself. But according to the analysis, after 20 meters it starts to become more sparse and less dense. We might have some issues in the detection of the process itself.
Mm-hmm. Thank you.
A similar question to what I asked the previous speaker. From the time you show up in the morning, how long does it take to do the aerial and the UGV mapping so that you can then take action?
Okay. So we have foreseen times of 1 hour, 1 hour and a half, up to 2 hours, which means that the deployment of the UAV itself is not an autonomous deployment. We might fly over the area knowing a priori that the area itself might be infested. And then all the processing phase takes time, and it also varies according to the number of mines that might be present on the field. So the more mines there are, the more data has to be processed, and the longer the times of the processing itself are.
Okay, and one more question. Yes?
Okay, I get the final one, thanks.
Yeah.
What would you identify as your team's unique innovation in your collection of things that you put together?
So probably, I'm thinking, the knowing a priori where the UGVs might be deployed thanks to an aerial survey. So avoiding to waste resources in terms of UGVs that might explode, as I was addressing in the previous question. So having an a priori idea on where it might be. And also the thing that we would like to introduce FPS view, thanks to the VR deployed on the top of the UGVs in the neutralization phase to keep the operator in the loop. There might be a new solution to the mining issue, probably. Thanks. Okay, and see one more. Okay, one more question.
Thank you for sharing ideas. My question is, becoming easier and easier recognize conventional munition, kind of mines and so on. It depends on the database and library, and artificial intelligence can recognize it easily. What's about the improvised explosives?
All right. Of course, the IED with respect to the EOD, we know what the EOD may be, and so we have different data sets. But thanks to the usage or the fuse of the 3D information and the 2D information, the detection of objects themselves from the land is something that is taken account into this phase. Because we go and we approach something that we don't know what it is, but we have an approach. And always the operator is kept in the loop to have the view onto the interface. So it might intervene if something he sees, he might think of being an IED detected. Because of course, I've not talked about magnetic interference today, but the IED might have some very, 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 very low quantity of magnet reacting components or nothing. So this is why it might be an issue. But having the operator in the loop with the detection itself on the field might be an improvement to the detection phase. So fusing not only the algorithms, always having the human eye in the process. Thanks.
Okay, thanks again. Thanks for your pitch.
Thank you very much.
Best of luck. Fingers crossed for the final results. The jury, now we have a team which is number 5 on your list. So it's a BROSWARM, Payload for a Drone, Revolutionizing the Demining Process with Innovative Drone Payload Solutions, team from Lithuania. Okay, do you need any help? Okay, good. So start whenever you're ready.
Can you hear me? Okay. So while my colleagues are doing the setup, I'll start. We are BROSWARM. I'm so glad to be here. Actually, I'm so proud to work on this topic. Only 1 year ago we started this. Me, my brother, my good friend. Obviously, we noticed this global landmine crisis triggered by Ukraine, the situation in Ukraine, and living close to the enemy. We saw that there's a much deeper problem, you know, in post-war countries, even 10 years after. We see such a high death rate, half of them children, so we couldn't stop to, we just had to do something about it. And me personally, I'm an entrepreneur for 20 years now. My brother is a physicist and machine learning software engineer. My good friend is an engineer. We had to do something about it. Obviously, the situation in Ukraine is worst as possible, the most contaminated place. We all know that. And then we got deeper into this problem, and we saw that it's a 100-year-old technology that we are still facing now in the fields. Even if we say that we put it on a drone, on a rover, doesn't matter. Most sensors are so old, and we need to innovate this area, obviously. So we look at this as obviously an aerial solution. We feel that this is the most has the most relevancy for this topic. Scanning an area and identification for hazard objects. Detonation is not our focus. The most important part for us, and it's a very difficult topic, obviously, is to detect the landmine. So, key elements of our technology. We can put our drone here somewhere just to show a case. Oh, it is here. So, key components, obviously, what is needed is routing technology, swarm control technology, next fusion module, our main component, I guess. Of course, machine learning software, which is put in our solution. And we have an additional one, we call it UXO locator for the sapper. I'll talk about it later on. So if to go just from the beginning, what we do is we are building a handheld device where sapper could go to the field. Obviously, as we learned before with colleagues that were on the stage, we mark the zone. I think the most important part, we want to be as universal as possible, so we cover the standards of NATO using our GIS systems and so on, so we could be as universal and integral to the NATO system as possible. After selecting the area, we do have two phases. First phase, as we call a macro view and eagle view, it's even 10 meters above the ground. So this phase is mostly important for the high speed and to detect basically anomalies. It could be UXO, it could be any man-made object, it could be a stone and so on. Later on, and we create a map of these, we call it points of interest objects. To understand more what's the object, we come to the second phase actually. So based on the object that we already know, it could be a metal, it could be a rock or something man-made. By that we plan which sensor must come to the exact place for the second scanning. It's more in-depth scanning, more closer, but still at least we aim 2 meters above the ground, which is very important for us. We don't feel that we could go lower because we know the fields, we know what's going on in Ukraine. So, which much larger obviously data, and we can now understand more what exact object we are looking at after the second stage. So, obviously this could be done with one drone. And we are drone agnostic. This could be up to 16 drones as a swarm, and we're building a software for that also. It just depends on your resources, obviously. So most important part is this baby that we've built. It is obviously a model sensor platform. It's built to be very universal, and we are not a drone company. We aim that we are a payload company. We don't care about drones, at least they carry us obviously, but our focus is this, and we want to be as most drone agnostic as possible. of course, most important components are in this control unit. Obviously, we're working with the most popular components: visual cameras, thermal cameras, magnetometer, metal detector, GPR. The system aims to be a universal platform to put any sensor, obviously the main sensors that we have now, but it could be any other future sensors. So we want to be as universal and sensor agnostic also. All the data that's gathered from different sensors are layered, obviously, with the machine learning, with our algorithms into one layer, so we could have a more precise view about the object. And finally, of course, before that, I want to speak about this. To understand the data, and so we could layer those and use machine learning. Of course, we need data, and this is a huge problem, obviously. For that, we had to create, and we thought we didn't have any choice. There's no data, on internet, so, and we couldn't go and work on the fields and gather because it's so difficult to do. We had to figure out how we could manage to build our own data set, our database. So for that, we created a robotic platform. This is a platform, works now, even now when we are here standing 24/7, gathers automatically data with multiple environments. Once in a while we change landmines, bury it, etc., etc., and multiple sensors also. And the platform is also, as you see, is holding our module. So with this, we are building such huge database. We think that it will be the biggest database very soon, if not already today. Obviously, after understanding what's the object, objects are marked in the map. Some predictions of what kind of object it is, and all of that is sent to a handheld device. So I'll stop a bit on here. Is that we feel that we are not changing, sappers soon, very soon, maybe even in 5 to 10 years, and we don't want to. Actually, we believe that we really working hard to create something for them, something that would allow them work safer and more efficient. So for that, we created for them a handheld device. We call it UXA locator, which is put with an anchor on a metal detector, or could be held in hand. So you could walk on real time and see what's in front of you after we did the scanning, after we did everything. So basically this shows that we are still very heavy on this doctrine of detecting landmines, and want to improve this rather than just change it. All the data is gathered to our cloud. It could be used on any NATO standard data systems like TAC and so on. And here, I guess we feel that is, and I can say this is hygiene. I think that every company here today must do something like this, and but for me, it is the most boring part that I've talked about. So we feel that this is not enough. We feel that this will not change, and we can see already now that the technology that is used is just not enough. It's just not accurate. The accuracy, 95%. Who cares about 95%? We aim at 100. We wanna have 100. And for that, we started to look into the place where we could find something very potential. And in our mind is GPR. So obviously GPRs are used already on rovers, on the trying to use them on UAVs, but the results are laughable, I guess, on the drone. So it has such enormous limitations, obviously, especially if it's used on a drone. It just has no resolution. It could find barely on a drone, it could find, you know, a large pipe or something like that. Nothing small as a landmine, obviously. It just has no resolution. It's, if you put it far above the ground, there's a lot of noise of the ground surface itself. So I guess I'm so proud to say first time we're showing to the audience actually, and we have, I think, an investor here that invested in us, so even they never saw this. So first time live speaking about this and showing this, we created something very unique that has never been done before, and we call it X-ray Eagle. A bit about it in short. X-ray Eagle is a mixture of technologies. Obviously GPR technology, which you already know, but first time we combine GPR with SAR technologies, synthetic aperture radar technology, which is used in planes, in satellites, to have a better resolution, a higher resolution. And combined with our, I can truly say we have a genius in our team, probably one of the very, very brilliant geniuses in the world, maybe even. We created our proprietary spatial reconstruction algorithms, very high in mathematics, to be able to construct something very unique. So apart the resolution, which is very important, obviously, now with this technology we could also see the depth. We could see to some degree the sides. We can understand it not from just look it from the above and see a glimpse of something, but we can go in depth and to see basically a potential 3D object. So obviously why just speak about it? I must show about this. So here are some items. This is, I don't know if you see, this is a very small one. I'm gonna show this one also. This one. This is so small. And a scissor, a nail scissor. You can release it and start it. A bit about this concept that we're working about our sensor technology. This is a miniature, obviously a miniature scaled version. It's for demonstrating, for working in the lab, for us to experiment and so on. This is using GPR and SAR technology in our algorithm. It scans the object through different angles. It collects data through different angles. And by this we are enhancing the resolution basically of these objects. Obviously this system can be used very above the ground, use all the frequencies that is possible. We can penetrate the ground, it depends on the frequency. The concept is just to showcase you how detailed we have and view and how we can see the depth of it. So if you see, we have 3 layers. On the top we have, I'd say, I don't know, a pin or something like that. On the second layer, a bit lower, we have scissors, a nail scissor. And on the bottom, a very small, I don't know how to call it, a round metal object. So small, is on the bottom. So now the system scanning it and making the object visible. Basically, this is our software, and we can start by looking from the above, basically. We're starting the view above the ground. So at the top, we have a pin, such small item, Second layer, we go deeper and deeper, we can find a scissor. Never been with such clear resolution. And the third layer is the small pin of that metal. Also basically never been probably done before. And all of this is seen through all three layers. This is very important. With these layers, and possibility to have these layers, we are able in the near future to reconstruct the object. So our aim is not to be, how to say, not to be, not to think and have results of AI. And we feel that with AI currently we will have 95%. We want to be able to show the object for the human eye. It's a totally different approach. We want that the human eye could see the object and decide it. What's the object? If it's man-made, if it's a rock, if it's a landmine, and so on. Not by a signal strength, not by predictions, algorithm predictions, and so on. So our aim is to build a technology where a human eye, a sapper, could itself just redefine what's the object. And later on, we could build around it, you know, AI, like prediction by the vision that we have. But we are aiming to have this very precise object that we can see above and below the ground. And I'll just end it, you know, as usual, this is my phrase that the true peace comes when the land is safe. So I hope this tech finally will change the direction that is now in Ukraine and in other areas. So thank you very much, and questions.
Thank you very much. Thanks for very visual presentation. It's good to see
it's working at least
the working device and the working solution.
Yeah.
Yes, dear jury, please, your questions.
For first question, I got a couple, but on the X-ray Eagle, any kind of limitations related to soil type? So if I'm looking at clays, if I'm looking at mix of rock, various types like that.
We aim to investigate any soil. It's actually we are able to investigate it. With this X-ray, we're able to see what type of soil we have. If it's like more muddy, if it's, and so on, it's watery, etc. Actually, this X-ray exactly is able to predict what type of soil it is, even to that degree.
And there's no interference with being able to identify the objects within.
Yeah, exactly. This is our aim, by having this super high-end resolution, like super resolution as we call it.
And then the next question was on the sensor package, the standard sensor package with Next Fusion.
Yes.
Are all of those integrated into that package? So Next Fusion contains, you know, it's extensible obviously, but it's got the different items you.
Yeah, it's set up for multiple sensors, as our aim from the day first was sensor fusion, obviously, because it's the way to go, like our colleagues said before me, and maybe some other potential sensors in the future. But we feel that the main sensor that we left at the end of our presentation is our unique sensor Eagle. So with this combined obviously with other metal detectors, magnetometers, which is very limited because they need to be very low to the ground. And with our technology, we can be 2 meters above the ground. We could be 10 meters above the ground. So
that's the real trick, isn't it? You know, what's held back synthetic capture radar all these decades is it's incredibly power hungry and requires a lot of data processing.
True.
Help me understand, again, how long it takes, how difficult it is, how often you can fly.
True. Karolis, maybe you could help me on that? Is my brother, by the way.
Hi, my name is Karolis. Well, good question.
right now, of course, the data is really hungry for energy consumption, at least right now when we generated that image with the spatial holography technology, it makes about over billion calculations. So on my laptop, that image would be generating like 20, maybe half an hour. So we send the data, we are filtering it on the device side, send the data to the central computer, and then we can spin it up on large stuff like GPUs and so on.
Maybe I will add that the data is processed not in our drone, which is obviously battery, consuming, but the data goes through encrypted channels to the main computer, as we call it. So.
Okay, so you can be processing while the thing is still flying. You don't have to come back, download, and process.
Exactly.
Okay.
Exactly.
Thank you.
Just to add, actually, when the data comes in, you already see things are already appearing up. And when you collect enough data, then they start up to be more clearer. That's the idea.
Any other questions that you remember? Yes, one more question.
I'm quite interested in the data setup. Can you, if it would be deployed to some area, can we then say, for instance, we send you some soil, some type of dirt, and then like we found this and this. Can you give us a mock-up? Is that possible?
By coordinates, you mean, and by
sampling and put it into the database?
Yes, obviously. Yes, I think so. Yes, obviously. Yeah. We could search your pockets now.
It's fine.
It's fine.
A similar question. Given where you are right now, what kind of pilot project would you envision would really be helpful to move you to the next step?
No, everything. We aim to work, and we are now started to be in some our local MOD events, and not even events, but working on a project with them. So I guess locally and abroad, we feel that maybe until this year, and we could go to the fields, obviously with the sensor fusion stuff that we have, which is we call basic, the boring part. But with this we need obviously development, and we need resources. Just very low funded, personal money, and very low pre-seed round. So we're aiming to raise a good round of investment now, after we have this proof of concept, and I hope that we could push it, faster. And obviously we'll need some setups. Our aim is to go to Ukraine and then to showcase and to see it in Ukraine fields.
Thank you very much. I see there are no more questions. Thank you, team. Thanks
you
for the great presentation. Good luck. Yeah, better be safe and not damage all the equipment. And now, dear jury members, the team that is number 1 on your list. It's the AAI Labs VR 3D Warzone Area Maps, utilizing virtual reality to create detailed 3D maps for mine clearing. Team from Lithuania, please set up yourself well. The mic is there. Either you grab the mic or you can use the mic stand.
Hello.
Okay.
Hello everyone. My name is Henrikas Gradziauskas, and I represent the company AAI Labs. Today, I'm going to present our ambitious idea for utilizing virtual reality for mine clearing using machine learning, drones, and virtual reality. So a little bit about what we do. We are a software company founded in 2018. We provide AI solutions for both the private and the public sector. And the areas we specialize include generative AI integration, voice synthesis, AI vision, and many others. Also important to note that we are currently co-developing drone systems based on 5G technology, where we try to monitor urban transport infrastructure. And some other projects we do also include Eurostars, GovTech, 5G Sandbox, InnoBranda, and so on. So, that's the problem. That's the boring part done. Now the problem we are trying to solve is landmine detection, and it's pretty obvious that this is a crucial problem to solve, since we still have, up to this day, about 4,000 to 7,000 landmine casualties every year. And the traditional methods being currently implemented can be very high risk, can result in the casualties of human personnel, can also be inefficient. It can take up to 1,000 man-days for of human man-days just to clear up 1 square kilometer of land, and it's slow and labor intensive. Also, landmines can be hidden in very difficult terrains and can just be simply too remote or too hard access by human personnel. So the solution that we are proposing is very ambitious, but we plan to deploy drones with various multispectral cameras, as well as various sensors, including ground-penetrating radars, acoustic sensors, and then we plan to collect all the data into a single pipeline, where we process it with machine learning to be able to detect, to predict the location of the landmines, and also with the help of satellite imagery and photogrammetry, we would create a virtual reality environment where users can interact with the map of the area, with the landmine locations detected, and assess and proceed safe planning of the future missions. So, putting sensors on drones and cameras on drones is nothing new. It's being done for a long time and being applied successfully. However, the real innovation here is a combination of all of the different data sources into a single pipeline, and then processing them with powerful machine learning algorithms in order to have enough data to be able to create a virtual environment solution where users can interact with the battlefield before entering it. And a little bit about data collection. So, like I said, we would use multispectral cameras. These cameras can capture more data than the traditional cameras, the digital cameras we know and use. We would also use ground-penetrating radars and acoustic sensors to capture different frequencies of different wave frequencies of objects both above the ground and below the ground. And we would also integrate the system with satellite imagery for large-scale mapping. Now, the data processing. Once we have all the data collected, we can then transfer it to a local powerful computing system. We would transfer the data using secured real-time protocols based on MQTT standard. These protocols can also be integrated with existing NATO systems, and then we would use the data, use the sensor data to predict the location of the mines, of the threats, and also use geographic information software for preparing the data for creation of the 3D maps and spatial analysis. Now, the creation of the 3D map, once we have analyzed the data and we prepared it for the map, we can use API of well-known SDKs like Unity 3D and Unreal Engine to generate a virtual environment. And we can also use Blender API to automatically create 3D models. And once we have the models, we can integrate everything into VR hardware such as Oculus. Now, some accuracy measures we would use to validate the system. So we would calculate number of explosives identified correctly relative to the total numbers in the whole area. And we would also use the false positive rate, which is the opposite, objects incorrectly identified as explosives. We would also calculate average distance between the actual locations of mines and their predicted locations. And we would calculate the percentage of correctly neutralized explosives out of all identified explosives, as well as the time average it takes from the detection to neutralization of a threat. And some targets that we shoot for. These are ambitions, but given our previous experience in projects and given consultations with experts in the field, we are trying to have a 95% of correctly identified explosives, 5% false positive rates, and the average distance of incorrectly identified explosives 6 centimeters. As well as 19% of correctly neutralized explosives and 27 minutes once the explosives is found to its neutralization. Now a little bit more about the system architecture. Like I said, we will have multispectral cameras, as you can see on the left. Drones equipped with multispectral cameras attached to sensors, and to those drones will be attached sensors like ground penetrating radars and acoustic sensors. Then we would also integrate the system with some satellite imagery, and we would transfer everything to a central processing unit using the secure transfer protocols. And then in the unit we can make predictions for a drone, make predictions for landmine locations, as well as use GIS software to prepare the virtual maps. And from those we can build the virtual reality experience, which users can interact and explore and plan future missions. Now, some simulation capabilities for planning explosive neutralization. So we would have a virtual reality environment. Users can explore it, users can interact with it. The environment also has the location of the detected mines. Users can also plan ahead drone neutralization missions, They can select from robotic missions to drone-based missions, and test out different options and find the most cost-effective solution. You can also test out different pathways, different routes, and everything in a secure environment without needing the human personnel to be in the real world. You can simulate in the environment and avoid unnecessary casualties. Now, the system is designed with safety and reliability in mind. We would have multiple drones performing the operation, therefore increasing continuous data transmission, ensuring backups and lack of errors in case something went wrong. Also ensuring the accuracy of the data, the integrity of the data, since having multiple drones can help with the more accurate metrics. Now also we would have various diagnostic tools, which diagnostic and monitoring tools which help us to ensure the operational stability of the system. And also the system would be secure since we would use standardized protocols, and it would also use minimal training from, it would also require minimal training from the personnel, since it's very much based on UI experience and it's very intuitive to use. Now, traditional methods usually require a team of people to perform demining missions, and those teams include surveying and detection team, can range from 20 to 40 personnel. Also, a neutralization team can take from 25 to 30 personnel. Safety team can take up another 30 personnel, and in total we have 65 to 100 different people just to clear out 1 square kilometer of land, versus our proposed solution where we only have 10 personnel for remote surveying and detection. We also have only 3 to 5 people for virtual planning and remote neutralization. We would also need only 2 to 5 people for safety and command team, and in total we only have 15 to 20 personnel per 1 square kilometer, which is in total about 80 to 85% decrease in manpower required on site. So that's it. That's our solution. Any questions?
Okay, thank you very much. Thanks the team for the presentation. Okay, jury members, please.
Yeah, thanks. Good presentation. You indicate a 5% false positive rate.
Mm-hmm.
Isn't it really false negatives that you want to minimize? Because that's what explodes and kills people.
What we wrote false positives. Let's basically we're trying to identify the objects that we have got wrong. So the false positive rate.
Now, false positives means you've identified something that maybe you thought was a bomb, but turns out it's not really. The hard part is finding things that you don't know what they are and turn out to be bombs. That's the false negative rate, right? So go ahead and walk in that direction. Don't worry, everything's fine, except then you explode.
Yeah. But we included, all of the presentation is up to the research, and we included the metrics as guidelines, let's say, and it's up to the research to decide what are the best metrics for the solution, and I think it's a good idea to include false negatives as well. Thinking about it now.
Yes, Thank you. Any other questions?
Thank you for your presentation. Excuse me.
Okay.
Could you elaborate a little bit about the integration of satellite imagery? Is it for detection? Is it for the initial imagery? Is it commercial sources, open sources? Thank you.
It's mostly for building the 3D environment, so we use it for large-scale mapping, and then we can combine it with photogrammetry and georeferencing. We can build more accurate 3D maps of the environment.
Mm-hmm. Now your question.
Captain Lutus, thank you for your presentation. I just have a question. Is the system you're designing built for humanitarian demining or military demining?
Its idea is to build for military demining, but actually we haven't specified, we haven't classified that directly. I think it can be used for both. It's still in idea stage, so the real implementation could differ, and we could apply it to both fields or the one that would be most useful for.
Because I think I have a remark about this. So when you're talking about humanitarian demining, you're preparing a location for people to live. And I noticed in a couple of these wonderful presentations, it says 95, 98% is the rate that you're looking for, the success rate. But the thing is, if you're doing humanitarian demining, you're telling that people can live there. So I think you should strive for 100% always, because then if it's 95%, the method that was invented 100 years ago still has to be done, because you need to be 100% sure that people can go and live there and be safe. So I think 100% should be the mark everyone should be looking for.
Thank you. That's a great remark. Yep. Yes, please.
So properly understanding, this is at the conceptual phase.
Correct.
Okay, so my question would be, what's the unique innovation in here?
Come again?
What is unique in this concept of the things you're putting together? You've got a visualization system, you've got a detection system, you've got the other stuff. Where's the, we say secret sauce. What's the innovation?
So that's the secret sauce. We're collecting huge amounts of data in order to, from different sources, from different sensors, in order to have enough information to create a 3D environment, which is extremely difficult. And that's the research part, and that's the innovation, that's the ambition.
Okay, thank you very much. Are there any questions? We still have time for one question from the audience. Yes, please. I will bring the mic.
Yes, I'm Andres from Team Varuna. I have a question for you. You said that you use audio data as one of the data channels. What data are you using, and what data on the channel you get from the mines?
So we can use audio data to detect landmines. We can basically sound waves into the ground, and then see how different like frequencies reflect different objects differently. And that's just one of the sources that it's up for the research states to detect what is the best source, I guess. And it's just one of the ideas to use for the drones.
Okay, thank you very much. Thank you for the presentation. Thanks for the answers to questions. Round of applause. Yes. Okay, so all the best for the previous 5 contestants. We have done the first batch. I think we have been sitting for a while. Now it's time to stretch, to walk around a little, to do some sit-ups, and of course to have a lunch. So we have a 1-hour break. We continue sharp at 1 o'clock. Okay, now it's sharply 1 o'clock. I think, you know, there are two conferences where you are not allowed to be late. So it's the project management conference and military conference. Okay, so guys, we continue the NATO Innovation Challenge finals. We have 5 teams to go, so please, teams, pay attention to the clock here in the screen. So you have 20 minutes for presentation and leave about 10 minutes for Q&A. And I think it's just simply a good moment to invite next team on the stage. So we have the second batch of 5 teams. And I invite Eagle AI 4D, explosive detection and neutralization platform, cutting-edge platform for enhanced explosive detection and neutralization from Lithuania. Welcome on the stage. You can use that mic if okay. Good. The stage is yours.
Hello, everyone. Hello, everyone. I'm happy to be here in this very important challenge for solving a very global problem. So, I am Jokubas Drazdas. I am an entrepreneur working in the field of artificial intelligence mainly, and also engineering. And today I will like to present our joint team solution, Eagle AI 4D, which is the very complex platform for enhanced explosive detection and neutralization. So the global problem is over 60 countries are contaminated with landmines, causing around 5,000 casualties annually, with 80% of being civilians. Actually, we have the shortage of the miners, and sometimes it's even expensive to prepare and time-consuming process. Mine clearance machines and the other technologies are quite expensive as well, and also they require a lot of investment even in maintenance and acquisition. And what we see in recent time, that lessons from Ukraine shows that mine laying technologies are advancing rapidly and becoming stunningly effective. That's why Ukraine is one of the world's largest minefields, covering 170,000 square kilometers already. And that's why innovations like was presented today can change the game. So what is Eagle AI 4D? It is actually early concept. It started from some solutions which was produced as a very early prototypes to assist persons who is fighting in the Ukraine, who are working as the miners. So Eagle AI 4D is a modular solution designed to make landmine detection and neutralization safer and more efficient. Main focus is accuracy, because we cannot let to even 1% of mistake made. Efficiency, safety, and minimal human intervention. So main models of this concept is drones for surveillance. It's just for quick aerial survey to spot suspicious areas and prepare for the mining operation. Robotic platform equipped with sensors for precise ground detection. AI data analysis tool, which helps to analyze all the collected data with robotic platform and drones. And also our concept of laser neutralization model and mine detonation trailer and mobile headquarters. For the first sight, it looks a little bit difficult to understand why there is a lot of modules for this solution, but I try to explain you why. So let's start from line detection modules. Stage 1, detection. It was, I think, every one of us knows that drones can be used with very simple RGB cameras and thermal vision cameras to collect the data, to do quick survey of some specific area. But we know that it's just like first step to start and to prepare for operation. So using collected data and AI, we can get some results. Actually, guys from Ukraine provided us some material. It was done with a simple drone for 1,000 euro and with RGB camera and one with a thermal camera. It's more expensive, but still it's civil, nothing special drone, quadrocopter. And it was achieved quite good results, even from the very simple solution, because we can identify some mines in the line field. If you can see with the eye, computer vision can identify those mines as well. But there are some challenges, and with drones and also with those cameras, because of environmental conditions, terrain complexity, and that's why we cannot be very accurate with solutions like this. We can just do short, quick surveillance to prepare for more complex operation. So we know that from the Ukrainian lessons, I heard that almost 30% of landmines is buried. It's under the ground. So it's very difficult to identify them. So that's why if we want to be very precise in identifying the landmines, we should need more sources of data to be more accurate. That's why we prepared the concept, because we understood that drone sometimes cannot operate in very forestry areas and so on, maybe sometimes in because of vegetation and other environmental conditions. So first concept of multifunctional robot platform prepared is just visualization made, because we are working on the concept now. But for our plan is just for land detection, two main tools. So ground penetrating radar and metal detector. So this robot can collect the data from the specific area, and that data could be analyzed in different paths to identify possible locations of landmines. But still there is some challenges, because there are a lot of false positives, and actually for us it's main task to clear the anomalies and so on. So we are now working on this. Second part of the solution, landmine neutralization modules. And actually it looks very primitive, but it was asked from the guys from Ukraine to prepare something very similar, cost effective, to demine, to neutralize the personal landmines. And just it's a very early prototype, but he looks very primitive, but he's effective, and we already tested it. And it could be used in agile operations, or if we need to clean the path for concrete direction in the most cost-effective way. Because we are planning that this the mining trailer will cost less than 10,000 euros. Stage 2, we understood that this mini trailer is also not very universal. It can help and assist for some operations only. But that's why we looked at this problem more sophisticated. And according to the guys who is every day working as a deminers, they said that landmine burning is one of the safest ways to neutralize landmines. The miners in Ukraine, for example, use this method, especially when they low on explosives and detonators. By igniting the landmine, any traps or additional explosive are also neutralized, so ensuring the safety from the distance. And it's very easy process, nothing special. So that's why we prepared the concept. And with mine neutralization with lasers concept. Actually, lasers, according to my colleague, lasers technology shows promise as a way to neutralize landmines from distance. And a high-powered laser beam is focused on the mine's casing. The laser hits the casing, causing it to breach. Ideally, the laser's power is controlled to initiate a deflagration or rapid burning of the explosive rather than detonation. So deflagration is much less dangerous and doesn't scatter shrapnels. But also, we have here some challenges which we have to solve. So laser-based mine neutralization systems are still under development and require testing for real-world deployment, because there are also a lot of research on this done already. But still, I think that it's very promising technology and could be used very universal. So that's why I think it is possible to solve these challenges. So another one is precise control over the laser's power is crucial to avoid accidental detonations. And lasers may not be efficient for neutralizing buried mines as their energy gets absorbed by the soil. But later I will show you that already some research was done, and this challenge, I think, could be solved as well. Some laser parameters which could be important. So wavelength, pulse duration, and power density. And for some examples with which approve our direction which we are going. So one research was done regarding neutralization of anti-personnel mines. So demonstrated compact laser system which was capable of destroying tested landmines from a safe distance of 50 meters. And it's quite impressive to ensure their safety. The working distance of the deployment system can be varied in a range from 5 to 50 meters. So laser radiation duration is the range of few minutes. Laser incident power in the range from 20 watts to 60. Another example, also test trials were conducted at a standard range of 50 meters with 20 degrees angle of attack. The lasers was focused to sublimited spots using telescope, and targets were 1.05 millimeters artillery rounds with the composition B explosive fill. 3 types of overburden was studied: sand, oil, and gravel. Laser neutralization capability was demonstrated under these conditions for live rounds buried under 7 centimeters of dry sand, 4 centimeters of soil, and 2 centimeters of gravel. So I think that that challenge which I was talking about previously could be solved with landmines as well. Also, great example how laser demining technology is developing, and this is also solid state heat capacity laser beam to hit target ordnance to the point of causing the explosive filler to ignite and start to boom. Range is very impressive, from 25 to 300 meters, and neutralization time of less than 2 seconds. That's why we invited one of my friends, engineers from Finland, who developed armored vehicle, multi-purpose armored vehicle, which could be as a mobile headquarters for remote operations and efficient transport for equipment, troops, and also this solution, this armored vehicle is already tested. It's quite impressive because it has capability anti-drone, equipped with anti-drone equipment, and it's very important now because we know that a lot of drones now in Ukraine is used to attack. So to be safe, we should be safe and to ensure that the miners is safe in the operations. Also, this vehicle is quite good protected, and you see all the tests was done already. So we have different possibilities, different configurations, but I think that in complex it is fulfilling all the solution very well. So very simple concept looks like this in this slide. So we have data collection, data analysis, and neutralization. So first step, to collect the data with quick surveillance with drone, using RGB cameras, thermovision cameras, and multispectral cameras. For artificial intelligence to analyze this data and to even to do photogrammetry is not a problem at all. Actually, another solution after this, the data analyzed from the drone provides recommendations for operation, and ground penetrate and robot starts his mission with ground penetrating radar and metal detector, and that collected data will be analyzed and also provide the concrete coordinates of the mines. And later, it depends on what we want to achieve. We can use trailer for the mining and laser. And actually, all these components can be used as separate products. It's just a model, so for us it's important to ensure scalability of the solution. And mobile operation center, which can help to transport all the equipment, the miners, and also to ensure that safety from the equipment and people. Our core team, as you see, our solution is very complex and very difficult, so that's why it's a joint team from different sectors. And actually, my background is cybersecurity and artificial intelligence, but I started originally from cybersecurity and originally became entrepreneur, which is working on artificial intelligence. But we have a professor from university, 2 professors, one is experienced in artificial intelligence, another one is in drones. And I'm very happy that Rimas Armaitis accept our suggestion to be our team member. This person was working in Ukraine and as a deminer for 2 years, and now he's in Lithuania already. And I believe that his experience and lessons learned and the newest newest knowledge could contribute to this solution a lot. Also, we have Romualdas Trusovas, Dr. Romualdas Trusovas. He's quite perceptive laser technology expert. And also I invited two guys from Estonia, as I mentioned, the guys who have a lot of experience in R&D, robotics, automotive, who has working experience in SISU, for example, developing some military vehicles, and they accept to be a part of this project. So that's it. Thank you.
Okay. Thank you very much. Now the round of questions from the jury members. Anyone has a question?
Yes, I will. Thank you for your presentation. I have also, as a tradition, a couple of questions. First question is, what is your system resilience regarding the adversaries' electronic countermeasures?
Actually, at the moment, we was not solving this. Challenge, but we was thinking only about some products which could be used for ensure our safety in the operations, for example, but not as this. But it's a good point. I think we could consider this as well.
And what is the operational distance of your robots regarding the personnel? Distance between the personnel?
We believe that it will be up to 2 kilometers, but it's very optimistic. Actually, minimum task for us now is to do it in 1 kilometer. So I think that it's very realistic to achieve it.
Thank you.
Thanks.
Okay, thank you. Next question.
And then at this point, is this at concept stage, or have you progressed past the concept stage and you're actually testing out the subcomponents?
Yeah, as I mentioned, we started from the small steps only because it's our side project. It's not as it's a joint team. It's a very complex solution, but we thought that if we can join our knowledge, experience, and skills, we can prepare this. Yes, so it's a very early stage, and but those mini trailers already like tested. It's like very early prototype, but I think that in 1 month we will do quite good final prototype, and maybe we'll try to use it in for example, to test it in Ukraine. So I believe that it's also very promising solution because it's very cost effective, yes. And as actually the artificial intelligence algorithms for analyzing the data from simple cameras or from thermal cameras, so it's also not a problem. We are providing services and working also on our solutions. So we have quite good knowledge because we were working, we have one solution in medical sector where we applied artificial intelligence. So it's also it provides recommendations, and we achieved 95% already. But also even one mistake can lead to the death or the harm for the person. So we understand that this is the same. So we achieved quite good results in real-time data analysis as well. So I think that our knowledge can contribute to the solution as well.
And then the second question is, what in the system you're proposing, what unique innovation do you think you're bringing to the table?
Actually, now it's as I said, it's our side project. Every time, like the main problem for the developing solutions is investment. So I think when we will prepare the final concept, I think that maybe we will start attracting some venture funds or something like that, because I think that it have quite big potential.
Good.
Yes.
I think what everybody's interested in probably is the laser. That seems to be the most innovative part of what you're proposing here. question then becomes, well, first off, I believe we're mostly talking about anti-personnel mines. We're probably not talking about anti-tank mines, correct? Yes. So in that environment of anti-personnel mines, how precise do you need to know where the mine is in order to shoot the laser accurately and effectively?
Actually, we need more research to be done, yes. But I think that from the first, in the first stage, what we, according to the research we've done, I think we can not be very precise. Maybe even 20% can be, 10% can be like error.
Okay. Yes, next question, please.
One short question. Thanks for the presentation. In your system, do you envision to incorporate also additional sensors from other platforms, or is it not foreseen at the moment?
Excuse me, could you repeat it, please?
No, is it possible to integrate into your system also the data from additional sensors from another drone, from another technology? Or is it open, or is it a closed system?
Actually, additional data could be analyzed as well, and we saw that Palantir, for example, United States company, already signed a contract with Ukraine government to analyze the data regarding the mining as well. So I think that additional sources could be analyzed in the future, which could assist and contribute, for example, for operation planning and identifying the most risky areas and so on. So I think that it could be in the future as well.
Yes, one more question.
Okay, thank you for your presentation. My question is, how many do you expect laser engagements, the one charge or one attempt?
Actually, as I mentioned before, it should be more research done. But as we see from the studies, it could be used even not, because that's why we involved that armored vehicle, because of the energy power, yes? So that's why we are not thinking now about, how to solve this problem, because I think that the energy source we will have from this armored vehicle.
I mean your robot.
Sorry for that. Regarding the robot, we are planning. That's why we are thinking now what kind of engine to choose, because first of all, it was request to do it fully electric, but it's not very effective. So now we are thinking about the hybrid model. So I think that it can operate at the moment maybe 2 hours. It's very, I think, optimistic.
Okay. I don't see no more questions. Thank you very much. Thanks a lot for your presentation. Again, audience, please. Round of applause. Thank you very much, and also good luck in the challenge. Perfect timing. Thank you. Group number 2 in this batch, it's the Ethicronics, if I pronounce it right. It's integrating satellite and drone technology, enhancing security in conflict zones with a blend of satellite and drone technologies. UK. Thanks for coming. The stage is yours.
Hello everyone, thank you for the kind introduction. So yeah, my name is Frank. So on the program it was written in France, but as you can hear I'm French, but based in the UK, based in Cambridge, where we think we can develop technology for good. And at Ethicronics, a small startup, we develop software for hardware problems. First, so I'm not going to spend too much time on the problem. I think we did cover this already. So we do have some company values. I will just look back to be sure I have the right one. Leadership, collaboration, impact, humility is very important. I think
I've learned a lot the last few days here, so thank you for that. And we do believe that with technology, we can bring transparency. Then I don't know if it's a good thing or not, but we can do that, and I think we can achieve this role. Also, thank you for all the people working on defensive solutions here. And of course, yeah, thinking of everybody that is involved and impact right now. So this is the outline of the talk, 20 minutes. Just one slide on the reminding what is the challenge. So I will use NATO ICT slide. Then I will move to what we think can be of value, and we look forward to having some expert feedback on this, and we explain like how does it scale, how effective it is, and so on. So yeah, at Electronics, I think we have a background of innovation, and I hope a future of impact. And also at the end of the talk, I'm going to talk about what are the next steps if this technology is of interest for NATO, of course, but for anybody in the room as well. So first, demining challenge. So one part on detecting where you have some mines, and also another part on neutralizations, of course. And we were aware of these different requirements: effectiveness, safety, innovation, scalability, and integration. So not a new problem, and we know in the current second largest country in Europe, it can block potentially some counteroffensive and also kill injured civilians. And what I want to point out is that particularly post-war, this is useless to have mines. So I think it's a very important point here. So of course, it can restrict access to different places, use of land for farming and so on, and also for people to have some peace of mind. So we know also that worldwide, lot of injuries, I think it was about 50% happened in Ukraine, people killed by landmines. Yeah, so you have this problem. Different mines out there. As you can see, I'm not the expert in mines, so I did take a little Wikipedia screenshot. But yeah, we know different types of mine, different type of detectors. Can be plastic mines, can be metallic mines, and so on. It has a direct damage, but also I want to point out the pollution side, because yeah, it's going to be out there. It's going to have an impact when it does explode, or where you set it on fire to potentially like neutralize it. Same from the Telegraph. I'm from the UK, sorry. So yeah, just I took this picture. So we know anti-tank, and also anti-personnel mines that, for instance, can be brought to land from with different aerial means. And we know about land mines, sea mines, and then I don't know if there are some air mines, but anyway. So also I wanted to mention missiles that are still in the ground, non-exploded. Every year back in France also you have this. And so yeah, this is something we don't know where they are as well. And of course, unfortunately, it's not a new problem, so you have some solutions. There have been some work in this subject. There's like a paper from 1995 from someone in Lausanne about like all the different sensors you can have. So yeah, it's something not new, with different problems, different ways to actually clear mines, yeah, with robots and so on. But then I wanted to talk about what is new today. So I think in terms of satellite precision, also I'm not the expert on this, but we do have some interesting resolution of, let's say, 30 by 30 centimeters. And I do believe that with some clever software engineering, actually you can push this a bit further. And yeah, you have civil, and also military satellites. And also, yeah, they have some problematics in terms of daylight, if it's cloudy, if it's a place where a lot of war activities are going on as well. And also, yeah, maybe your field of view doesn't cover everything yet. Today, a lot of yeah, software capabilities, let's mention AI if you want. The cost of number of drones are very small nowadays. And I think that there are some potential solutions here without developing everything from scratch again. And the very important point is that, yeah, we need to go fast. And the good thing is that, yeah, people are looking to develop this kind of solution because it has some direct impact. So this is what I wanted to present today. This is about what we think would be of interest. We want to make a map of all the mines that you have. We want to use soft technology, a lot of security involved as well. But basically, we think that with satellite imaging, you can do a lot. Of course, you can see maybe a plane passing by, dropping some stuff. You can do a lot of things. You can track people as well. You can see if they stop somewhere, do something. I'm not the expert on that, but I think there is many things to do around this. And then there are different ways to store this information, of course. But I was thinking like, in a way that is secure, and maybe during the war, nobody can access it. But maybe post-war, if you have the right keys and so on, actually, you can know exactly where you have a mine. So then you can go and do something about it. You can either populate this map of mines with your satellite data, or actually, you know what you have yeah, sent to the adversary, so you can just put it in a map as well. Of course, maybe it's not for everybody, but yeah, happy to discuss about these kind of things, because mines, at the end of a war, this is useless for everybody. Also, you can store the information about where you have missiles. You use a lot of drones during the war. Maybe you can use some drones a bit at the back to check, oh, actually, this missile has not exploded and so on. So I think there's a lot of things you can do in this kind of area. And what is also interesting is actually you can, you know where you have something that doesn't explode, for instance, and maybe you can use this to train your AI if you have then another method to extract the thing from the ground or actually stop it. And I really think that with strong security, privacy, you can have this kind of map, and it could be applicable, and you could be able to, yeah, at scale, just cover a lot of mines. And this kind of mapping would be of interest, yeah, for any land or sea. It's the same kind of application. In terms of neutralization, I've just put it on the same slide. But yeah, we have a background, a bit of reverse engineering. So I think, again, you know what kind of mines maybe is on the ground. So for instance, yeah, you know that, let's say this plane or whatever is going to drop this kind of mine, or this kind of person will drop this kind of
of mine. Yeah. Then I think there might be some smart ways to actually neutralize this kind of equipment. And I think if you have this kind of satellite-based imaging and or drone-based imaging, actually you know for sure which one you have next to you at scale. And also, we need to think about, is it good to actually make it explode? What is the pollution, even if maybe it's not the top one priority? But yeah, is it better to actually just ignite it and put it on fire, or find a way to stop it? On this part, we're not expert at all. We have a bit of background in hardware as well, but I think our main part is the software, the security side of things. So of course, satellite resolution. This is one thing, but we do think that intelligence can help to track the different operations. And I think for whatever is human-made, there is a way to actually track as well. So what is behind this is actually knowing or catching basically what happens before it's below the ground as well. If maybe you have some way to intercept or whatever, or you know for sure the precise location, and and even if your resolution is not that big, maybe with a speed of maybe a setup speed, or the speed for the missiles or the mine to go to the ground, maybe you can have some site share information to tell you this is what I have at this precise location. And then you can think of alternatives to get these images, signals, balloons, drones, and so on. You can gather information from securely. You can gather information from the different data source you would have in a conflict. And I do believe that it's a fast and cheap way to actually know where you have some lands and some mines. And it's not specific to metallic one and so on. And if you start with farms, maybe it's going to be easier to test and implement. So as mentioned, a lot of different complexity here, and it could be applied to different data sets. So I think in terms of effectiveness, it's quite interesting to actually see where you have the mines. And and also I wanted to say maybe there are some ways to neutralize a device by having a load that you can drop and maybe take it back if exploding is okay. But I will just come back to this. So I think it does cover different places, and it's fully remote, and also you can detect where you have maybe missiles in the past. So I think it's rather creative, and this is a collaborative effort where different nations can actually insert in a secure and a lot of privacy around way, and you can use it for mine clearance as well. And I think with a lot of software you can resolve these resolutions, for instance. And it doesn't have to be on future data only. You can use past data. Scalability, as you can guess, and then in terms of integration, the idea is to use existing data. It's software, so it goes very fast. A lot of security involved. My team is very strong on that. And it can be a dual use as well. And for instance, you can think about even a civilian. He could have the right
the right information on his phone to actually walk around. And we do believe that if you integrate this very far, you can have 100%. You cannot have false negative, because you know that a plane has been there, someone walking there has been, and then you know that nobody has put a mine, for instance. So happy to engage further with experts in this topic. Then in the last 4 minutes, so I think just as a first step, I would get 2 Cambridge intern software engineer to work on this. So of course, study resolution, feasibility, what you can extract from other fields, and also create this kind of platform with security at heart. And you want to go very fast with company data, with AI as well. So myself, I'm ex-Thales, I'm ex-Cambridge Fellow, and I've been a CEO of Avionics for 2 years. I know a bit about hardware-based security. I've been part of one NATO anti-tamper workshop, for instance. Then I have someone very strong, a PhD, Oxford, in software security. A lot of guys that know about machine learning in Cambridge as well. The master is oriented machine learning. And then right now, so it's not public yet, so I'm not going to say much, but we just got funding to be 4 people full-time. Not on this, I want to precise, not on this drone technology. And then we also applied for 2.5 million funding to be 7 from October. The core flagship project of Avionics, I just want to mention, because I know that we have experts in the room. We develop a software to ensure that your electronics hardware is not fake. And same, this is 100% sure that from a full system down to nanometers, you have the right hardware in your hands. We have been through different funding and different support, and I'm very thankful to that. And we do believe that this hardware assurance is one of the missing puzzle pieces for digital security. So today, I wanted to express this this interest in actually solving the mining challenge at scale. And I think it's very specific because you do need a lot of corporations, and it's very important to keep a lot of data secure and so on. So I know that we are a small startup, but we'd love to collaborate on this kind of problematics. Also, my team is very international in Cambridge. I try to keep the best talents from Cambridge University in Cambridge in Avionics. So I think this kind of project would be a good way to keep them so in the UK. And we need the right data to do so. So but thanks to a background in software, in different type of security, I think we can push for this kind of solution. And also, I just wanted to mention, I'm still doing some teaching, different outreach. So this kind of project would be of very strong interest back in Cambridge. So thank you again for your time.
Thank you, Frank. Thank you very much. Thanks for brilliant timing. Now the time for questions.
Thank you for your presentation. I have a question regarding your hardware. Who is going to have access to this?
So I think first we can develop maybe per country, and then the idea is that you can have different access. But basically, if you are a NATO country, maybe you can give the access to the right person. I think with technology you can block the access, and of course we know that getting this kind of data, maybe more from advanced satellites, is going to be a tricky one. But
And also I mean access in regards of secret classifications, like information. If I put my own minefield into the system, it's a NATO secret. So is any protection from unauthorized personnel to go into the hardware?
Yeah, so I think with, for instance, like for our main project, which is hardware assurance, we use design files as input. And these design files is also quite critical. They cannot go, it's different level, but also they cannot go elsewhere. You cannot enlarge the attack surface. A lot of different things like this. And I think for this, also with the right piece of technology, it can be like transparent. Like people, they know like exactly where it goes, basically. And yeah, for instance, like you can see it one time off, or you can just see where you have a mine. But I think, yeah, you can lock to the right person the access. And I'm really thinking like maybe post-war. For instance, if for instance, let's say I'm Ukraine. I have a key. Then on the other side, they have a key as well, and maybe, yeah, everything is completely inaccessible for anybody in the world. But then, if yeah, it's done, then you want to clear things, you know, and maybe it could be a way. Of course, it's sensitive during wartime, and also maybe a lot of politics around this. I'm not the expert, but I do think that, yeah, with software, with security, privacy involved, it can be useful, maybe. Yeah. Thank you.
Okay, thank you very much. Yes, please.
So, correct me if I'm wrong, but what I'm hearing here is that your primary, what's new here, is integrating satellite data with drone data or other sort of closer to the ground information. What specific kinds of satellite data are you imagining you'll use, and what kind of resolution do you need from that satellite data in order to be effective at mapping it?
Yeah, so for this I could ask some interns, very strong computer science from Cambridge students, like to work on this, but basically we don't know how far military satellites go, but even with a 30 centimeter resolution, we can, with some techniques, pretty sure we can go much, yeah, much closer to, yeah. They have different ways, because like, maybe it's gonna be dropped from the air. There are like a lot of different ways around this, and I think the innovation is more like around the map, how to securely have an input to this map, how to have it properly secured, and have the right standards as well associated to that. It's not breakthrough technology, but I think could solve. It could be complementary to solve a part of a problem. Yeah.
Okay. One more question. Yes, please.
Just trying to understand it. It looks like you're proposing to put a team together to provide a solution to the challenge versus coming in with a solution to the challenge. What am I missing?
No, you're right. We do have funding for the hardware assurance project. We applied to another big project, which is more about secure computing, still related. But if we have first some expert feedback, and then if this is of interest to actually test, we can work on this. I have, I guess some of them, they will be online. I had to say no to some students, very smart students, coming from all over the world to Cambridge, and in the end I said, like, I'm sorry, I don't have the funding. So I think it would be this kind of perfect project for them.
Okay, thank you. Thank you very much. Thanks for your presentation. Thank you. Again, round of applause, dear colleagues. You know, active applause makes you awake after the lunch break. There's always that, you know, black spot, or how to say. So, third team in this batch, team number 3, it's Varuna, if I pronounce it right. Varuna 98, groundbreaking solution for demining operations, team from Latvia. Welcome here to the challenge. Please, welcome on stage, and the stage is yours. That microphone, that is the mic. Yep, and the slider if you need. Thank you.
So, greetings everyone. I'm Andres from Team Varuna, and it will be my pleasure today to show you some innovative approaches to our mine problem. Well, I start with a challenge and tell you a simple story. A few years ago, I was at the training range in a military exercise in Latvia, and we were going with my squad on a small forest road, but a quite popular one. And my squad mate noticed something suspicious on the ground. When we took closer, we decided that this metal piece is suspicious and left it to engineers. We found out that it was an actual live anti-tank mine. Not armed and lying upside down, but it was lying there from the Soviet times. Everybody was driving over it. I was driving over it. So, these mines, they are everywhere. And the problems are that there are large numbers, enormous variety, all the different kinds of them. And actually, you don't want to approach such weapon. Many times you have to operate under enemy presence, so you have to be very fast to do it effectively. Other challenge is that actually you don't want to blow up the mine, because in many cases you will damage infrastructure around, you will contaminate the area. And it's not just mines, it's also UXOs and probably unexploded ordnance is even more numerous, and IEDs, which doesn't have the normal classification. So, what's our approach to the problem? For the safety, it means you will have to operate remotely. It means there is a carrier module that will carry all equipment to the target and back, so the operator is always safe. For the detection, there is scanner module, a set of detectors which you will use to scan the area and find your targets. What are these targets? Are they mines or not? That's for that's recognition, and that's for the control module. And to neutralize the targets, there are two cases, the combat case, and that is the Stinger module that can destroy these mines very quickly. And then there is collector and processor modules that will do it slowly, but do it safely for the infrastructure. Let's go through them. For the carrier, we will use a large carrying capacity drone. It was a decision between UAV and UGV, but knowing all kinds of complicated terrain and the risk of UGVs to trigger the mine and got themselves destroyed, we went for UAV. The platform is pretty open, just like the whole architectures of system. You can replace any part with something else that does the same. Routing and navigation is autonomous. There is, of course, GPS, but as it flies typically low, there is visual and inertial navigation, and if you really need it, you can put 2 support stations that will provide navigation on site. Carried this model is by the light vehicle, think good old Humvee, and carrier docking station allows to recharge it. Now, the scanner module is a set of multiple sensors GPR, magnetometer, there is environmental and thermal cameras, and as option, what to do when you have this mine that has no metal, no normal signature, nothing. We can put a chemical sensor similar to ones used on explosives detectors in airports and other secure facilities, as all these sensors should fly very low above the ground. It will cut off speed and make limitations on operational conditions, but it may sniff out the explosives when nothing else would notice them. The mobility and construction is similar. Now, the control module, the brain of it is essentially software that runs on a high-capacity PC. You can have it on a site, or you can operate it remotely through the network, but that's where data are processed and signatures recognized. We make the signature type of recognition primary, because AI is good, but there's a big problem. How will you share your recognition capability with other systems? Signature data can be brought to common format and shared easily and quickly. But AI, when you have different systems with different algorithms and different implementation, not so much. Generally, you would need to share learning data. And that can't happen fast because the system must learn on this data. Here you do mission planning, status, see the results on map. Also, typically, not all cases you will be able to identify automatically. There will always be some non-standard cases, and then you can decide how you deal with them. Now, once you identified your targets, or maybe got them from some other system where you identified where they are and what they are, there is a simple and fast solution. And because normally when you fire that anti-tank mine, you use a demining charge. It's done by military engineer. We mixed our capacity on demining charges with our knowledge on drone-delivered gravity bombs, and we just bomb them out from low altitude, applying a proper type of the charge for the proper target. That's how it happens fast. Equally, this module can be moved around and deployed in the same way than others. So, what we do when we can't blow up the mine? The problem with mine or any dangerous explosive device, what makes it dangerous are explosives. So what if these explosives just went away? Is it possible? It is. We put a collector module on top of our target. It has additional sensors to analyze it more precisely. And then we drill a small hole in it and use appropriate solvent to wash out explosives. It's a slow process, but it's very unlikely to trigger explosion of the mine or unexploded ordnance. And once the explosives are away, well, then you can remove it freely. So, what if there is not enough of the solvent? That's why modules with the solvent is a separate module, and the same carrier can carry work fluid away and carry back a new set of the solvent. So, before going through this, I will share my current problem and my current frustration. And that is, of course, explosives. We are doing demining charges, we are doing drone warheads, and these are all currently fill-on-the-site products. Why? Because there are no explosives available on the market. When I meet somebody, first question I want to ask, hey, maybe you have somewhere 30 tons of hexatol lying because I really need it. And I don't think the situation will resolve quickly, because to scale up explosives production in Europe or in the United States, it will take some years to really do so. However, there are a supplier who has explosives. He's willing to deliver them to me free of charge. There's just one simple problem. They kind of set to blow up with my face. And if that problem can be solved, then I have my perfect supplier. That's where all that dissolved explosives go. Processor unit, which first contains all the modules for the operation. And second, there the solution is slowly recycled and explosives extracted. So you can probably have another module right besides it and fill them back into your own charges or products. The size and mobility is of a shipping container. Now, this is the dessert. In the specific cases, when you have a mine that is light on surface and doesn't have an overtly sensitive anti-handling device, there is a very simple solution what to do. You use the transport module and remove your obstacle, enemy's anti-mobility solution, and just move it to the different place when it becomes your obstacle and a problem for the enemy. This is a simple imagination how a potential operation would look like. Let's say you have encountered a minefield, typically a rapidly deployed one during your operation. So you will need some kind of distraction operation. You can't really expect that enemy will leave the place unattended and let your engineers act freely. Then you send in an engineering team. Close to the enemy, you would need some support for electromagnetic warfare. And then in a very short time, you can map where you want the corridor, scan it out because the area is small, detect the mines. It's a bit simpler because you know very quickly what type of the mines are there. There is a chance that you detect some non-standard situation which you can't have time to solve, but then it's a decision of the engineers how to deal with it. And so once you know the mine coordinates, you bomb them out quickly, and you have reached the obstacle. You can continue your mine operation. This is a sample of how the long-time operation would look. Let's say the park there over the river is contaminated with exhaust infantry mines, maybe some anti-vehicle mines. So the platoon with a large module goes there. There is scanned thoroughly to find everything and be very sure. You would find a lot of objects and some non-standard cases. And then slowly but effectively you will recover what's on the site. Remove all dangers and separately deal with the cases that system can deal. So, why go for our solution? It's scalable, it's automated, you can operate it remotely. These all modules and capabilities, you can easily replace them with capabilities in your own. For example, you can use just the scanning part and do traditional way, or go for our competitors and send in the lasers. Or you can have well-detected mines from other system, pass the information through your command and control system to ours, and bomb them into oblivion. There is a unique, environmentally friendly way to deal with the mines, and as Minister of Defense Industry of Ukraine said, large-scale war is first of all economic competition. And here is just a small step in the right decision to conserve resources and raise availability of those that we are critically lacking. So, who's behind this project? The company is called TETAS, it's a Latvian defense company. My line of products are engineering products. We also do some system integration. We may be a small company, but we rely on a large supply chain. There are actually a lot of capabilities behind. And my full name is Andres Andreas. I have background in physics, and I've worked as a source of the most technical things and innovations in our company. So, thank you. I think I did it faster than expected, but then you have more time to torment me with your questions.
Perfect. Thank you very much. Thank you a lot. Round of applause. Thank you. So the hardest part is done. Now only easy questions. Yes, dear jury, do we have questions? Who might start? Yes, please.
So is this at concept stage, or have you moved some of these along?
Well, different parts of the projects are in different stages. For example, on mine detection, we had a project on scanning for mines with GPL and magnetometer. It was perfectly implementable, and we were planning to go to Ukraine. I can share privately what happened to the project and why I'm here and not in Ukraine hunting for mines. But from technical point of view, it was a working project. There are actually pretty much already capabilities in the market for this. Now, on the Stinger type effectors, we are producing demining charges. We are also will start to produce warheads for drones and gravity bombs for drones. If you want to see how a 100mm class looks, come next week to Eurosatory to our booth. In process is development of 40mm gravity bombs for drones, and the plan is to integrate our capability in the mining charges with one in gravity bombs. So this part it's not in final stages, but it's pretty well developed. This year we started to offer drones for Latvia and for the drone coalition. So let's see how it goes, but now we have capability on drones too. The least developed part is the collector part. I would say it's about technology readiness level 3. There are some things done and tested, but physical prototypes are not yet rolled out. I would really like to put additional team on this and do a 6-month research only project.
Okay, thank you. Yep.
Check. Of this, what would you say your unique innovations are that you're bringing to the field?
The mine innovations? Well, in each field there are some. I had a really good idea here to try to use acoustic channel for detection. We on our side offer to use the chemical channel for detection. Yes. Mm-hmm. This whole system, as a system, it doesn't have a very big groundbreaking innovation, but it has a lot of small things in how it's controlled, organized, the level of autonomy in it. Then on Stinger type mine destruction, it is a combination of existing capabilities, but it is also something that is not yet in the market. Some other competitors I see also are innovating in that direction. And of course, the part which is most innovative is dealing with explosive targets in a non-explosive and safe way, and recovering the materials and going towards more economical and more effective way of war. Haven't yet seen anything seriously done in that direction.
Okay.
Right, thanks. I'm curious about a couple of things. You mentioned using signature data instead of AI models. How do you keep the signature data up to date when the enemy is creating new kinds of mines, new sorts of things? How do you keep your signatures up to date?
But that is relatively easy, as the system or any compatible system is operated in the field. This data are collected all the time, and once they are set to a common format, they can be used directly. Dissemination happens very fast on operational timescale. For the AI learning, as I said, it's possible to share the databases for the AI training, but they also need to be implemented and checked, and the dissemination of that information will happen on strategic timescale.
The other thing that interests me is you called it your transport module. That sounds like a very complicated thing to do. Can you enlighten us a little bit on what that looks like, how it works, and why you think it's a good idea?
So it's actually not that complicated because in a very simplest sense, there is an object on the ground. You need to pick it up and put down somewhere else. And you typically use a grabber that goes at the ground level from sides. It fixates it on friction basis, and then you slowly move it to the next position and release there. As I said, that will work only on specific narrow case of the mines. Two conditions must be true. But as we see in Ukraine, these conditions tend to be true from large enough cases for that solution to be interesting. It also attacks not just enemy mobility, but enemy morale, adding insult to injury.
Okay. I don't see no more questions. We have a couple of minutes if there are questions in the audience. No hands, no questions. Thank you very much. Thanks for extensive answers.
Thank you for the attention. And let's meet in Euro Saturday with those who are interested in it.
Thanks a lot. I wish you good luck in the finals, in the challenge, and of course, soon we will know who are the winners. But in general, let me probably just simply emphasize that, first of all, it is a platform to share, to listen, to hear each other, to maybe combine intellect, combine brains, combine joint forces. So this is also a benefit and the value of this event. Okay, moving to the next team. It's the team number 4 in this batch. Unmanned Dynamics Integrated UAV and UGV Swarm Approach. Utilizing a swarm approach of unmanned aerial and ground vehicles for remote demining operations. Team from Lithuania. Do we have the team? Still preparing the pitch. Okay, so we probably... Sorry? They are over Zoom? They are online? Okay, okay. Okay, so... Okay, I didn't knew that they are online, so great. Can we then have them online here on the main screen? Let's check it. Okay, it's a couple of more minutes to manage so that we hear and see. Also, for the participants here in this room, I recommend a challenge as well. Try to think of the team who would you think jury will choose as a number one. So we will see, how accurate would be also your preferences. And let me also maybe remind criteria while you think and while you observe presentations. Criteria for selecting the teams are effectiveness, so how well does the solution identify and neutralize explosive-contaminated minefield areas, so effectiveness. Then the safety, what measures are in place to ensure the safety of personnel and the environment. Then the innovation, how creative and novel is the approach to remote reconnaissance and neutralization. So that's why there's a question always about what is the innovation in your idea. So please, for the two remaining teams, emphasize on that. There's a still chance to beat the other idea. Scalability. Can the solution be scaled for different conflict zones and operational scenarios? That is really very important. And of course, integration, which is how well does the solution integrate with existing military and humanitarian systems. So of course, applicability, scalability, efficiency, environmental friendliness, and all these are key priorities for choosing the number one idea or the number one team. If I'm gonna check. Tai galim tada mes imam kitą pranešimą, kitą komandą, šitos pabandom sutvarkyti per tą laiką, gerai? Ane? Okay, so still there are some technical issues, so my proposal is that we take the next team, if the next team is ready. So during the presentation of the next team, we will sort out these technical issues. So Virginia Uncrewed Systems, could you please then take the chance of presenting? Nice. So let me introduce, it's Virginia Uncrewed Systems, Minesweeper on the edge, advanced minesweeping technology pushing the boundaries of demining team from US. How was your flight? Long. Okay, good. Better than swimming though. Really, fantastic. Okay, so thanks for taking the stage, and the floor is yours. Yes, please. Great.
Hi everyone, my name is Mickey Cowden. I represent Team Virginia Uncrewed Systems. It's been an honor to be here in Vilnius this week and have the opportunity to present our Minesweeper on the Edge solution to the NATO Allied Command transformation for this iteration of the Innovation Challenge. Oh, where's the... Virginia Uncrewed Systems is made up of 3 team members, myself, Josh May, and Whit Milne. All 3 of us are from the south... Oh, is it? Okay. Okay, thank you. All 3 of us are from the southwestern region of Virginia in the United States. Josh and Whit are joining us virtually from their office. For this presentation, we'll briefly discuss the problem and what slice of the problem we are attempting to address through a specific use case. Then with that context, we'll go into the solution in detail, the team's expertise, and some other ideas that we've had for additional functionality, then wrap up. Nearly 70 countries and territories are still affected by the presence of 110 million landmines. In addition to causing loss of life and limb, landmines also restrict communities from accessing land suitable for agriculture and development, which exacerbates the humanitarian impact. The cost to remove a mine can be 10 to 10 times the cost of producing the mine in the first place. This disparity highlights the immense challenge that the world faces when it comes to demining. These threats are not new. They have been an issue for over 100 years. Every spring, European farmers uncover thousands of buried munitions dating back to World War I. This illustrates just how long-lasting an impact that this has on civilians and their way of life. According to UNICEF, there was over 1,000 civilian casualties globally in 2023 alone, triple the amount reported in 2022, of which 20% were children. These numbers have likely surged dramatically due to the recent conflict in Ukraine. The situation in Ukraine is especially urgent, with the nation becoming one of the most mine-laden countries in the world. Approximately 30% of Ukraine's land is contaminated, impacting 11 out of its 27 regions. The presence of anti-vehicle and anti-personnel mines, along with improvised explosive devices and unexploded ordnance, severely affects the daily life and economy. This presents a massive humanitarian crisis, with a cleanup estimated to take over 750 years, according to a GlobeSac report, and that's if we started now. Demining is a complex and hazardous process involving the detection and removal of landmines and unexploded ordnance, or UXO. These explosives can be found in conflict zones worldwide, buried or scattered across fields, roads, and urban areas. Deployed during wars and conflicts, often indiscriminately, they remain dangerous long after the hostilities cease. Techniques for demining include manual clearance by trained personnel and mechanical demining using specialized vehicles. The process is time-consuming and expensive, requiring meticulous attention to safety to prevent further casualties. The slice of the problem that we are focused on is how to contribute to the resilience of a column or convoy and safely and efficiently getting from point A to point B through an identified or suspected explosive contaminated area. The goal in our approach is to maximize safety and minimize the transit time in the context of active conflict zones, particularly those with above ground and recently deployed ordnance. While we believe our system could be extended to detect buried mines, we prioritize this initial use case based on what we thought would be most urgent and top of mind. Oops. Minesweeper on the Edge is an autonomous drone system designed to detect mines and ensure safe and efficient passage through minefields while reducing the immediate risk for personnel on the ground. In order to neutralize the immediate threat to the convoy, our strategy is to defeat each mine by evading it. The relative position of the detected mine is recorded in the system's map. If GNSS is available, the mine's position will be calculated using the drone's absolute position for future permanent neutralization. In hostile or GNSS denied zones, our solution provides avoidance strategy through terrain model mapping. It relays the estimated relative location of mines detections to support near real-time situational awareness. These mine detections are immediately communicated to user wearable devices and command control system. Examples of user wearable devices include an augmented reality or AR headset and a wristband proximity warning indicator. Additionally, the system will suggest a safe route in both the AR headset and the command control. The three major takeaways about our proposed solution are the sensor fusion payload, the machine learning pipeline, and how the system communicates with the operator. The sensor fusion payload is mounted to the bottom of the drone's airframe and leverages the drone's power and flight controller data. The operator interface includes a dashboard view, an augmented reality or AR headset view, and wristband proximity warning. The system will indicate flagged areas where mines are detected and suggest a safe route via the AR headset and dashboard. We will now take an in-depth look at our drone system's payload and describe how it operates. It will collect and process sensor data, then perform inference using this data to identify mines. The payload will be mounted on the bottom side of the drone's frame to have an unobstructed view of the scanning area. The payload will consist of a state-of-the-art edge computing module, connected sensor array, and interface with the drone's power system and data link. The data streamed from the drone's flight controller, which includes real-time kinematic or RTK GNSS and inertial measurement unit sensors, will include position, orientation, velocity, and acceleration information. This data will be used to localize the drone and map the environment. RTK positioning, which achieves centimeter level accuracy, will be used to determine the drone's receiver location. From this reference point, the geolocation of any detected mines will be calculated by localizing the mines relative to the drone. The members of our team have been collaborating to build a drone-mounted payload system that mostly matches this description. The sensor fusion payload was initially designed for surveying, mapping, and industrial inspection. It currently features an electro-optical camera, infrared camera, and mechanical LiDAR that are used to create a colorized point cloud, a global point cloud of the environment being mapped. We opted to perform active sampling via LiDAR system as opposed to reconstructing a terrain map via photogrammetry, so that we could build a global point cloud in near real time by immediately processing the observations made by the LiDAR. While these particular sensors can detect anti-vehicle and anti-personnel mines above the ground, additional research and consultation will be required with munitions experts to determine what other sensors this system can benefit from. We have designed our initial unit to integrate with the most popular commercial drone platform in the world, the DJI Matrice. This drone model has become a standard observation and deployment device over the Ukraine front. We are currently designing and planning to fabricate a custom VTOL platform in our facilities to carry the sensor fusion payload. Utilizing a patented quad-foil design from our licensed partner with the technology originating from Virginia Tech, which is a university in the southwestern region of Virginia, this drone will be able to carry more sensors and computing payload while increasing the flight times by over 50%, as we have seen in the most recent full-scale tests. This will offer a fully ITAR-compliant green UAS solution, providing a short path for adoption into the blue UAS market, allowing US forces to utilize this platform as well. The second major component I wanted to discuss is the machine learning pipeline. Machine learning models typically require a lot of data, from tens of thousands to millions of data points. Transfer learning leverages pre-trained models to improve performance on new tasks. It reuses existing knowledge, reducing the need for large data sets. This approach enhances accuracy and efficiency because the model already understands certain patterns, making it faster and more effective than training from scratch. For example, a model pre-trained on general images can be fine-tuned to accurately identify landmines in images, given a smaller initial data set. This results in needing significantly less data to create a robust machine learning model. Also, a vision transformer, or VIT, processes images by focusing on the relationship between different parts of the image. Unlike traditional methods that process images in small sections, VITs can see the whole picture at once, providing a more comprehensive understanding. This is particularly useful in tasks like landmines, where understanding the broader context is crucial. Landmines are often camouflaged or partially buried, making them difficult to spot. VITs can analyze the entire scene and identify subtle patterns and anomalies, such as slight disruptions to the ground or surrounding area, which indicate the presence of landmines. This makes VITs more effective in scenarios where context and detailed analysis are important. Additionally, there are methods available to pre-process LiDAR data such that the data can be made to be input to a vision transformer. Another important aspect of our machine learning pipeline is synthetic data generation. Synthetic data generation involves creating artificial data to train machine learning models. This technique augments real data, improving performance by providing more diverse and extensive data sets. A key benefit is the reduction in cost and time associated with collecting real data. For example, in landmine detection, synthetic data can simulate various scenarios where landmines might be found, providing ample examples for the model to learn from. This improves the model's accuracy and reliability in real-world situations. Using NVIDIA's replicator, we generated the images in this slide. The variations in these images make the model more robust by mimicking different conditions and complexities, ensuring it is robust enough to handle a wide range of real-world environments. However, nothing beats real data with high-fidelity annotations, and this remains invaluable for training our models, even with transfer learning and synthetic data generation. Real data provides a solid foundation and baseline, capturing the true variability and nuances of real-world conditions. It is especially critical for validating models to ensure their accuracy and reliability. By combining real data with synthetic data generation and transfer learning, we can create models that are not only efficient and cost-effective, but also highly accurate and robust in diverse scenarios. The main benefit of this machine learning pipeline is that the amount of real data required to build a robust model is dramatically reduced. The goal of our user interface is to support the way the operator wants to use the system. This would require discovery interviews with the personnel that would ultimately be using the system. However, we do have a vision for how the operator would receive information from the system. With a software able to give immediate alerts of the locations of UXO detections, we would like to develop a wearable device such as a wristband, which could give a proximity alert to the individual warfighter as they approach the location of a threat. This would be a simple and low-cost device. Additionally, for operators using augmented reality headset, this information would be immediately transmitted to the user's heads-up display. Mine detections would be indicated with a virtual flag or other visual cue, while a recommended path through the contaminated area would also appear directly in their field of view. A quick background of our team. I founded Cowden Technologies back in 2015 as a software services company, and have transitioned the company into developing robotic infrastructure for the purpose of enabling the continuous operations of autonomous drones. In recent years, the company has been working on several edge computing systems for drone applications, which include near real-time detection and using machine learning models and fusing sensor data from multiple data streams. My partners, Josh May and Whit Milne, both work for Autonomous Flight Technologies, a U.S. industrial research and development firm founded in 2012. Combined, they have over 40 years of uncrewed system design and fabrication engineering. We teamed up over 2 years ago to build our sensor fusion payload system that was discussed earlier. Together, the three of us are in the process of founding a joint venture named Uncrewed System Solutions, which will be the fabrication and retail arm of our UAS design and payload development that will leverage the intellectual property from our respective existing companies. We currently have a fully functioning fabrication facility located in Southwest Virginia, but are actively seeking a larger facility in our region. One of our projects that has been in development for several years is a drone docking station, which was recently awarded a second US patent. We think by integrating this platform with the vehicle and the convoy, we would be able to address the typical power limitations inherent with drone technology. The system would provide a battery swapping mechanism with a bank of batteries that would be rotated through and charged by the dock. The docking station itself would still need power source, either using power from the vehicle or another external source. Even though we have focused our research and solution design around the use case previously outlined, there are several individual components of our solution that are extendable or could be made to be modular to allow the system to adapt to other contexts, such as different scenarios, landscapes, and hazards. However, it'll take a combination of technologies to solve this problem, and we believe that this work would be an important contribution to that larger effort. So we look forward to collaborating with others today. Thank you everyone for your attention, and I'm happy to answer your questions.
Yes, please support your applause. Thanks a lot. That was a great presentation. The hardest part is done. Breathe out, that's okay. Now, you know, the easy part of discussion together with jury. Yes, dear jury members, please, your questions.
Thanks, Mickey. Yeah, good presentation. It seems to me, and correct me if I'm wrong, but it seems to me that the real magic here is the onboard computing capability you have on the drone. Can you talk a little bit more about what that capacity is, what device it is, and how you do that much processing on board the drone itself?
Yeah, thank you for the question. So the device is a NVIDIA Jetson Orin. It's a state-of-the-art NVIDIA device that they've come out maybe a year ago with. We think that we can do both the sensor fusion, where we're doing terrain mapping via the point cloud data coming in, as well as in constructing a 3D asset that can be used, as well as running the inference for the machine learning system.
I'll ask questions all day if you're able to.
Okay.
Talk a little bit about how the drone communicates to the wearable devices.
That's something we haven't fleshed out yet. We wanted to work with, use any standards that are available, or in the event that there isn't a standard available, be part of the discussion. So we looked into STANAGs, and I haven't found one that completely identify or is the standard that we would need to use, but it's a that's where we would start.
Mm-hmm. Yes, some more questions, please.
I have one. What I see here is that you will cross to a minefield or a mine stop or whatever we call it in military. But do you consider also, because it's always visual, but we have also anti-personnel mines with tripwires and so on. So do you have something with that in mind?
Not for something like a tripwire. We use the machine learning pipeline to create using a synthetic data set, which we would generate using expertise from a munitions expert, possibly working with a technical artist to come up with those 3D assets, and then the replicator system can create the variation that makes the machine learning model more robust. I think it'd be really tricky to measure a tripwire in particular. I don't have an answer for that particular scenario.
Okay, thank you. Yes, please.
Kind of the standard question, what would you identify as the unique innovation you're bringing to the table here?
I was waiting for that question.
I think the near real-time ability to do the detections and provide a map of the terrain. Since we're using active sampling from the LiDAR as opposed to reconstruction, that takes a long time with photogrammetry. Although photogrammetry works wonderful, we think by using the LiDAR and then projecting the camera, the images in the camera onto those called voxels in order to colorize the point cloud, and from there we can create a 3D mesh. But really the point of the system is to build that point cloud, and we can use some techniques to use that LiDAR data to also go through our machine learning model.
Great, thank you. Yes, please.
Yeah, really thank you for a good presentation. And I have a question regarding the sensor operational altitude. What is the maximum and minimum?
So for the LiDAR, I was looking into it earlier. At 120 meters, it's supposed to be able to have a precision of 0.5 centimeters standard deviation. The thermal camera that we use doesn't have enough resolution. The electro-optical camera that we're using right now is 64 megapixels, so we think that we could actually build a useful colorized point cloud or 3D mesh from 120 meters.
Okay, thank you. Thanks a lot. No more questions? Thank you very much. Thanks, and of course, applause and greetings to your team online. Thank you very much. Thanks for presenting. Okay, and now we have the team Unmanned Dynamics, Integrated UAV and UGV Swarm Approach from Lithuania, and the team is presenting online. Yes, do we have the team? Okay, we have it.
Good evening, ladies and gentlemen. It's a pleasure to present to all of you. So I'm presenting remotely, but my colleague Leoda is there in Vilnius in the conference. So today I want to talk about our approach and our solution for landmine detection and elimination, because we believe that just detection alone is only half the problem. And what we will present is a holistic solution which can integrate with existing C3 systems, as well as depending upon the situation, you can have either computing done locally or on the cloud. So a little background about our system, about our company. Our core strengths are in sensor fusion and guidance, navigation, and control. So we are one of those companies that makes their own autopilots, flight controllers, motor controllers, all of these things. The core technologies like the Kalman filtering, the AI, all of these are technologies that we have also adopted for use in this problem of mine detection and elimination. So just to give you some more background about what we do, since we design since all our flight control systems are designed in-house, it gives us the chance to make unique, exotic UAVs. Like, for example, this one, which is a combination of a coaxial helicopter and a traditional multi-rotor, can be gasoline powered, so you don't have any restriction on flight time. And it has many advantages and so on, which overcome the limitations of the cost restrictions of helicopters and the weight and endurance limitations of multirotors. What is also relevant for this, particularly relevant for this challenge, we believe, is a hybrid drone, which has much higher endurance of around 4 to 5 hours and can carry a variety of payloads. So all of these integrate seamlessly into our C3 system, which support a swarm of these systems. So, and the C3 itself is designed so that it can support a swarm of UAVs, coordinating with UGVs and so on. And the whole thing can be monitored remotely. You can say which areas have been cleared of mines, which areas are still infested with mines, and all of this data can be shared among participants seamlessly. So, coming back to this problem, what are the challenges that we face? One, there are multiple types of mines. They are buried at varying depths. Some may be just at the surface. Some may be maybe 2 or 3 feet below the ground. So you require multiple sensors to have a good probability of detection of these mines. And if you go, and no single drone can possibly carry all of these sensors. So our basic idea is to use a swarm of drones, each drone carrying complementary sensors, and then fuse the sensor data using AI and determine the location of the mines. So challenges that we will be overcoming are effects of temperature and lighting on reliable detection, and of course the limited flight time of the drones we will handle by going with a hybrid VTOL solution. But the sensor fusion aspect of our solution can be used on any commercial drone also. So in a contested environment, we also have the additional challenge of GPS jamming. And so in which case we would have to use one of our SLAM algorithms. Now, when we come to elimination, so we want to have a very simple, low-cost solution. So anti-tank mines, we get rid of them using disposable robots. And for anti-personnel mines, we just crush them with the UGV, which is again controlled by the same ground station. The UGV could be, for example, a modified heavy tractor. So, how is our background in flight control systems relevant for this challenge? Okay. So typically your drones would just do waypoint navigation. So for example, if there's a wind, then they would get swept away from the trajectory. And so potentially you think that they would be going on a straight line from point A to point B, but there could be blind spots which are missed by such drones. In our case, the drone actively follows trajectories or flight corridors. And so you can get extremely precise tracking because of our onboard sensor fusion. And when we combine it with RTK GPS, we are talking of less than 1 centimeter accuracy. And of course, in a realistic scenario, we have to contend with the fact that there would be limited access to internet, jamming of GPS, possibly electronic warfare, and so on. And the user interface also needs to be intuitive for easy training and mass adoption. So coming to our solution, what we propose is supervised deep learning, which is used to train the AI model with various, using various pictures or synthetic data of different types of mines. We know most of the mine categories that are available, and as newer ones are discovered, the model on the cloud would be updated, and that could in turn be downloaded to various edge devices which are used by the operator. So the model, of course, can be deployed on the edge or on the cloud, depending on connectivity. We would use swarms of hybrid drones carrying complementary sensors to sweep a grid pattern. And because of trajectory tracking, we can be sure that there are no blind spots that have been left out. So the complementary sensors could be like GPR, SAR, magnetometers, hyperspectral cameras, and so on. So C3 allows a single operator to control the entire swarm of UAVs and UGVs. So he or she can control up to a dozen drones. Collision avoidance is handled automatically by the flight control system by working in concert with the user interface. So there is no active user supervision needed for that. We can also have time-coordinated swarm flight. And this is especially important because one of the key innovative aspects of this proposal is what we call a software-defined radar, which is a low-cost, lightweight way of implementing a synthetic aperture radar. So the images which are taken by the drones, they would be stitched in real time on the edge to form a large mosaic of the area. In case there is connectivity, it would be uploaded to the cloud. An AI model, which has been trained using supervised deep learning, would be used to detect these mines from these images. So what we plan is to have images of mines taken with from various angles and lighting conditions using a variety of these sensors in order to train the model. And as newer mines are discovered, the model can be augmented easily, so it is a scalable solution. Once all your mines from, let's say, sensor 1 are detected, they would be correlated with the mines which have been picked up through sensor 2. And the whole point of this is to avoid double counting and false positives. So once your mines or most of your mines have been detected, you would the operator would then release the UGVs, and so the path would be planned automatically for the UGVs on the edge, that is on the ground station. And the whole point is that we don't want humans to traverse the minefield. So as little human intervention as possible is good. Of course, there are certain areas where human intervention is inevitable. Like, for example, if there are IEDs, then these would show up as suspect areas by the AI, and especially flag it for the user to then decide whether they constitute a hazard or not. Or, for example, if it's forested area, thickly forested area, then there's pretty much nothing that can be done by this solution. But barring those sorts of cases, once the path for the UGVs is laid out, first we would send a turtlebot. I would show you the one that we have in development. And this would be primarily to neutralize anti-tank mines or very large anti-personnel mines, and it could be equipped with a variety of explosives. It could also carry a line charge so that you can detonate a whole row of anti-tank mines if you want. And once your bigger mine, and this is necessary because there could be mines like the PTKM-1R, which would pose a serious threat to even the largest largest mine-sweeping vehicle. So the tractor or crusher UGV, it's basically a modified road construction equipment, and that would be used to detonate the anti-personnel mines. And then the swarm of UAVs and UGVs then moves to the next area and repeats the process. So what are the USPs of the solution? One, we are not dependent on electricity. That's why we want to use hybrid VTOL drones. Swarm compatibility is built in, so we can cover large areas simultaneously, and you can have different drones carrying complementary sensors. The solution method is extendable, meaning if you have mines from newer mines which are made, then you can train the AI model on the cloud and download them to all edge devices. The computation is not that intensive. We use NVIDIA GPU, and that would run on the base station, not on every single drone. We are actively working on navigation without GPS, so even in a contested environment and in the presence of GPS denial, we would be capable of operating. A centralized database is part and parcel of our C3 system and can be made compatible to all NATO standards. So this allows all users in the entire command structure to know safe and unsafe zones, to know which mine, for example, you don't want to be demining a place where you have placed mines. Then remote monitoring is also possible because of our C3 command and control system. The miniature synthetic aperture radar using FM frequency modulated continuous wave would significantly reduce the weight as well as the cost of the system. As I said, trajectory tracking ensures that nothing is missed. Collision avoidance is something that we have worked on and solved several years ago. In terms of personnel and the number of personnel required, we would like to minimize it as much as possible. So a single operator could control the whole swarm. And their intervention would be needed only when certain things are classified as suspect or unknown. And that's important because no AI system is perfect. And when you're dealing with something as critical as landmines, you cannot afford, you'd rather be slower than unsafe. And the whole concept of operations is slightly different for scenarios where there is electronic warfare and jamming. So it can be used both in peacetime as well as in an active war. So it is a true dual-use system. And even in terms of, so this is our hybrid drone for increased endurance and This would be a sample of our grid sweep, what we call as a grid sweep trajectory. Again, to minimize operator overload, he or she, they don't have to plot every individual waypoint for a trajectory like this. This whole process is automated at the click of a button and by entering a few parameters. This is our concept for the turtle bot. It's anti-tank mine clearing UGV, so it could be fitted with an explosive or a shaped charge. It could also be fitted with a gripper arm. It would use the same autopilot as our drones. And so by reusing the electronics and by using similar components, electronic components for these carrier vehicles, we reduce our overall cost because, as we all know, as volumes increase, production costs decrease. And now we come to one of the highlights of this approach. So we've been working with a radar expert off and on to solve this issue of detecting mines. So we don't just use, so the first point is we don't use just geotag position data, but rather we combine it with the whole IMU. So it's a true sensor field solution, which aids in very rapid, near real-time image stitching. And when I talk of image stitching, I don't just talk of optical images, but also radar images. And our drones can, they have multiple modes of swarm operation. One of the modes is to fly in a formation. And this can effectively be used to increase the aperture. We've been investigating the use of these modified software-defined radios to also act like radar. We have been also working with TI's millimeter wave radar as well. And one of the advantages of this approach is that it's quite a large frequency of operation. So the user on the ground decides what the radar frequency should be. Of course, he will just have like a lookup table based on the texture of the terrain, whether it's muddy, swampy, sandy, and so on. And so the penetration effect, the depth of penetration of the radar can be tuned depending on the local conditions. So, of course, the user need not know electromagnetism for this. They would just have a lookup table. And we have done some estimates of the payload size, and we expect it to be around 1 to 1.5 kg, making it feasible not just for our hybrid VTOLs, but for most commercially available VTOLs as well. So that was, I guess, a fairly short presentation at the end of a very long day, many interesting presentations. So I would be happy to answer any questions you may have. And my colleague is also in Vilnius for you to meet at any time.
Thank you very much. Thanks for the presentation. I hope you can hear applause.
Yes.
And okay, so now time for questions from the jury members. Yes, please.
Thank you for presentation. It was really a good one. But do you have any working prototypes of your products?
We had for the hybrid VTOL drones, we expect it to be ready in a month. For the synthetic aperture radar, it is a work in progress with our colleagues in Greece. And so it would certainly speed up if we had some funding for this. But this is definitely a problem that we are interested in because we believe that it's not enough to just look at it from the sensor fusion side or the drone side, but since we come from since our core focus is in both, this is a problem that we believe we can solve very well.
Okay, thank you. And the next question is, did you estimate operability of your system in wooded areas?
Wooded areas for the drone, I honestly, I do not think we would have reliable detection. So it would be for wooded areas, I think the best option would be to modify the UGV to go on the ground with suitable sensors and detect. And anyway, you can't send a heavy road roller type UGV into a wooded area. So it would be slow, painful, and I don't think a drone solution would work. Or you'd have to fly really high above the tree canopy and use a huge formation so that your synthetic aperture radar could penetrate the foliage and hopefully detect mines, but that remains to be seen. But I would not say that is a reliable solution.
Thank you for your honest answer.
Thank you.
Thank you.
Yes.
Again, similar to the previous speaker, the magic here seems to be your ability to do the onboard processing and use the software-defined radar as synthetic aperture radar. Can you talk more about what computer power you have on these drones that would allow you to do that?
Okay, so we can actually do two things. If we want to minimize the cost of the drone, we can have the Jetson Nano on the ground station. This is the configuration that we've been working with. Or if we don't really care too much about the cost of the drones, we can have it on board. So both of these options are possible. It's a question of cost for us, but since we have an IC engine charging the batteries constantly, if we go with such a configuration, then power consumption on board would not be a concern. The only concern would be having so many of these edge devices for each drone, as opposed to having a single edge device on the laptop. And from the testing and load balancing that we've done, a single edge device on the at the operator is sufficient for close to real-time data processing.
Okay, thank you. What, Jerry?
Yeah, great presentation. A question for you. As you identified earlier, the platforms are way up there in their technical readiness level. In the stack of technologies that make up your solution, which ones do you identify as being at the lowest TRL levels, and what's it going to take to get them up to the point that integrated system works?
Okay. So the lowest TRL level would be the software-defined radar, because we've started working on this only for the last 6 months. I would say they are at a TRL of 3 to 4. The drone system, the user interface, all of these are at a TRL of more than 7. So the C3, all of this is ready, and even navigation and GPS denied environments, I would say that is at a TRL of about 5. In terms of time, the software-defined radar, I would say, is about 6 months away if we had a team of 4 working on it all the time.
Thank you very much. Yes, there's another question.
Yeah, maybe a last question. How do you see the treatment of the UXO and IED found in the field?
Sorry, how do you?
How will you treat the UXO and IEDs found in the field? Because you give here an explanation just for the mine. Thank you.
Yes. Okay. So so the supervised deep learning model would also categorize areas that are perfectly safe as well as areas that are suspect. So, for example, let's say an IED is made as using a cluster of artillery shells, or it could even be unexploded ordnance by either side. So these would not be categorized as safe just because they are not mines, but they would be reported back to the operator. So the operator has to take a call on each one of these items that are suspect, and only after that would the UGVs be launched.
Thank
so
you
the
very much.
operator
Yes.
is an essential part of the system. He cannot be eliminated.
Okay, thank you very much. It seems that there are no more questions. Thank you for the presentation. Again, round of applause. Final presentation here.
Thank you.
Thanks a lot. So wish you all good luck. So all the participants and finalists here in this room, now we are going to have a coffee break, but that means that the jury will have the most, how to say, responsible and the hard part of the day. So to make the final verdict, to choose the 3 finalists. Of course, I would say probably all of you, all 10 participants that have participated, have already achieved quite a lot. Having the stage, presenting here, coming to Vilnius, and being the finalists. So it is at least 30 minutes, but we have some flexibility up to 45 minutes. So I want jury members to be, how to say, to be on the same page with the finalists. So jury members, please follow Marius, so he will guide you to the room where you can have the quiet discussion. And all the rest, please enjoy some snacks and coffee, and let's wait for the verdict of the jury. Okay, 4 o'clock, sharp. Jury has the verdict. Thank you very much for your hopefully tough discussions. It's been a long day, and thank you for staying here. Thank you all the 10 finalists for presenting, for your hard work up until now. Thank you for this platform we discussed. It started in 2017, I guess, in its 14th time, which is a great place to share, great place to hear and maybe to learn. But at the same time, all of us being here, we are responsible to continue. We are not allowed to just simply present and stop, because all the parties are watching this event. It's us here, but it's also, you know, someone watching and also recording and reporting. So it means we have to be fast. We have to actually be brave enough to develop further on. And I hope it will really happen, and we will see the results very soon. So it's an important part of the day where we will announce top 3 finalists. And may I invite hosts of this event here together with me on the stage. Thanks for coming, Erika. May I invite you together here. Erika Kurochkina, Vice Minister at Ministry of the Economy and Innovation. Yes, and of course, yes, please. And of course, Brigadier General Ivar Cotton, Deputy Assistant Chief of Staff Capability, NATO ACT, to announce the most important information of today.
You think so?
I think so. That's really, you know, they are really waiting for that.
Okay, we have had a great day today. We have heard a lot of inspired young professionals giving us their perspectives on various topics. But I will come straight to the point. So the 3rd place is AAEG.
Yes, congratulations. Time for pictures. Yes. Yeah. Final word?
That's for you. Thank you very much. It's very great honor to have this present, and thanks for the opportunity for us to present. And I understand that it will be followed by other presentation and other discussion, and this is super great. Thank you very much.
Thank you. Thank you very much. Okay, could you please stay here on the stage, because then we will have also the top 3 finalists in the joint picture. Yes, please, Mr. Chairman.
I guess the people are getting even more excited now.
Tension rises.
So, 2nd place goes to Unmanned Dynamics.
Yes, fantastic. Yes, please. We have a representative here. Yes, please welcome on stage. Thanks for coming. Congratulations, round of applause. Don't be so shy. Yes, picture. Time for the picture, please. Yes, thank you very much. Please stay here together with us. Well, Mr. Chairman, you hear the silence, you hear the tension, you can even hear the heartbeat.
And it's a tremendous pleasure to announce the winner, which is BROSWARM.
Yes, fantastic. Yes, thank you very much. Thanks a lot. Yes, and of course, please, time for the picture. Thank you very much. And maybe we can have a picture of all three all together, like all top 3 teams. Okay, could you please so then stand for the joint picture of all the finalists, top 3 teams. For the record of the history, and soon we will check how. Yeah, we have a projection on your faces from the. Ar galima tiesiog B tą blanką padaryti kokį? Yes, great. Say cheese. Thank you very much. Thanks a lot. Nice. There are still some emotions, of course. Yes, thank you very much. Yes, you can go. Yes, some little gifts as well from the Innovation Agency. Sergey, Erika. Mr. General, some final word?
No, I'm good. I think we have enough.
Yes. Thank you very much. This is then official end of the NATO Innovation Challenge Finals. Happy to be here, happy to help and assist this event, and of course, my strong wish as a civilian that all these innovations move forward a lot faster. So then we have impact and we have a peaceful world. Thank you very much. Thank you for participating. Thank you for applying. Let's wait for the 15th time of the challenge. Thanks a lot.